Welcome to part 2 of the CSS full course. Let's get straight back to it and continue learning more about Flexbox. It's now time to master one of the most common tasks in layout design, horizontally and vertically centering.
We'll be discussing centering with Flexbox, the different horizontal centering methods, the different vertical centering methods, and traditional centering methods versus Flexbox. Now this chapter is getting my more difficult stem. When I first started out, I found it a bit conceptually difficult to know when to apply different centering methods. So hopefully in this chapter, I've done a good job for you in setting out all the different ways we can center elements and the best use cases for each.
Now, as a heads up, this chapter is one of the longer ones, as I do go into a lot of detail, but it is my goal that you walk away confident with centering in CSS.
So let's first talk about centering in the context of Flexbox. Flexbox offers a modern and flexible approach to centering items vertically and horizontally. Looking at this page over here, we have a hero section which would all be inside a Flex container. Our Flex items would be the heading, the paragraph text, and the 2 buttons. Our main axis is in column running from top to bottom, which means our cross axis is running from left to right. Using Flexbox allows us to easily center our items horizontally along the cross axis. So I'm on this page we just looked at. I'm going to open up DevTools. I'm going to select the hero section. You can see that this is a Flex container. You can see the Flex direction is set to column, which means the main axis is running from top to bottom. So our cross axis is running left to right. And the Align Items property center is being used to horizontally center these Flex items. If I turn this off, you'll see they move to the left. So here's an example of Flexbox allowing us to center items very simply. Looking at another example, we have these cards over here. At the top of the card is an image, and this image sits inside a Flex container, where the image is the Flex item in green. Our main axis runs from left to right, our cross axis from top to bottom, and we're using Flexbox to both easily center this image vertically, as well as centering it horizontally. So I'm on the same page as before. I'm just going to scroll down to that section. So you can see over here, that image we just looked at. I'm going to select it. You can see it's inside a Flex container over here, and you can see both Justify Content and Align Item Center have been applied. I'll turn Justify Content Center off. Again, our main axis is running from left to right. So if I turn this off, you'll see it moves to the left, or Flex Start by default. And for Align Item Center, if I turn that off, you'll see by default, our image stretches because the default value of Align Items is stretch. Because the Flex container has a height set of 240 pixels, we can center the image. As you can see, there's space above and below for the image to move. So Flexbox offers a really neat way to center items horizontally or vertically, and horizontally and vertically. So I'm now going to be taking a detailed look at all the different methods available to us for centering elements. We're going to start by looking at horizontally centering a container. Now there are 2 methods available to us for centering elements. The first is using box model properties, where margin can be applied left and right to horizontally center child containers. To achieve this, we'd use the margin property, set the top and bottom value to 0, and the left and right value to auto. In diagram form, we'd have our browser, we'd have a parent container shown in purple, and our child container would nicely be centered inside the parent container, with equal margin applied left and right. It's important to note that the margin property is applied on the child container. So let's play around with this inside VS Code. So I've gone ahead and created an index.html file and linked a style sheet which is currently empty. What I'm going to do in the HTML is add a div. I'm going to give this a class of parent container, and I'll add another div and give this the class of child container. Inside this div, I'm also just going to go add some lorem text, just so we have some content. We'll head over to app.css. I'm first going to use the universal selector to just reset all the box model properties. I'll add a padding of 0 and a margin of 0. Next up, I'm going to select the parent container. And just so we can see it, I'm going to give it a background color of light blue. I'll select the child container. I'll give it a background color of blue. Let's give it a height of 300 pixels and a width of 300 pixels. So let's check this out so far in the browser. So you can see in blue here, our child container, which is inside our parent container in light blue. So using box model properties, let's go center this horizontally. As we saw earlier, we'll add a margin we'll set the top and bottom value to 0 and the left and right value to auto. Let's refresh. And you can see this nicely centers our child container inside our parent container with equal spacing applied left and right. So let's now see how we can achieve the same thing using Flexbox. Flexbox properties make it simple to horizontally center flex items. We can use the justify content center property when our main axis is in row. Remember, by default, our main axis is in row, which is horizontal, so we can apply justify content center. But if we've shifted our main axis, so that's in column, we'd have to use align item center to horizontally center our flex item. So align item center is when our main axis is in column. Looking at this in diagram form, we have our browser, our flex container, our flex item. For this demonstration, I am going to put our main axis into column so that our main axis is running from top to bottom and our cross axis is running from left to right. So to horizontally center our flex item, we would apply align item center as our main axis is in column. And align items is for centering along our cross axis, which is going horizontal. Now this works even when our flex container doesn't have a set width. And that's because the flex container is most likely a block element, which by default will extend the full width of the page. So even if there is no width set on the flex container, it will have width, which means that there's space horizontally for the flex item to move. It's also important to note that the Flexbox properties, justify content and align items, are applied on the flex container. This is different to the box model, where margin was applied on the child container. So let's play around with this inside VS Code. So I'm back inside app.css. I'm going to just comment margin 0 auto out. I'll refresh, and our child container moves back to the left. So let's go use Flexbox to center our child item. We do that by going onto the parent container. We give it the display property with the value flex. For this demonstration, I'm going to change our flex direction to column, which means our main axis is now running from top to bottom, and our cross axis is running from left to right. So to horizontally center our flex item, we're going to grab the align items property and set its value to center. I'll refresh, and you'll see our child item centers horizontally inside our flex container. And once again, this works because our parent container has width, which is currently the width of the browser. If I click on the parent container, you see it currently has a width of around 1100 pixels. So because the container has width, there is space for our flex item to move horizontally. So let's now continue our discussion of horizontal centering by looking at horizontal centering content inside a container. Looking at the box model first, using padding to create internal space left and right gives the illusion that content inside a container is centered. So we could use the property padding, set the top and bottom value to 0, and the left and right value to something like 200 pixels. Looking at this in diagram form, we have our browser, our parent container, our child container, and applying a padding value of 200 pixels left and right would add on extra space like this on the left and right of the child element. This would effectively give the illusion that the content inside the child container has been centered, especially if there's something like background color applied on the child container, as background color will both be applied on the content itself and any padding. The padding property is applied on the child container. So let's play around with this inside VS Code. So I'm back inside app.css. I'm going to just go comment out all the Flexbox stuff, and I want to uncomment out margin. So now we're back to horizontally centering our entire child container using box model properties. Let's now go add some padding. I'm going to give it a value of 0, top and bottom, and 200 pixels left and right. I'll refresh, and you can see by adding padding left and right, it gives the illusion that our content is centered inside the child container. If I open up DevTools and select the element and go down to the box model, you can see our child container is here with the content inside, and padding of 200 pixels has been applied left and right. I've just kept margin here to keep the whole thing centered, and let me just comment that out. And ignoring the parent container for a second, you can see on the child container, it still appears as if our content has been centered inside the blue box. So looking now at Flexbox, box model properties still apply on flex items, so padding still can be used to create internal horizontal space. So in terms of horizontally centering content inside a container, we can still use the padding property from the box model. Looking in diagram form, we have our browser, our flex container, our flex item, our main axis running top to bottom, our cross axis running left to right, and padding is simply just applied onto the flex item, creating internal horizontal space. And like with the box model, the padding is applied on the flex item, that is, the child container. So when adding padding, what effectively is happening is that the content inside the container is centered. So unlike before, where we were centering the actual container using margin or flexbox properties, we're just using padding to create extra space, which gives the illusion that our element is being centered. So let's go play around with this inside VS Code. So I'm just going to comment out the box model properties on the child container, and I'm going to uncomment out the flex properties. This gives us our flex item in blue, horizontally centered inside our parent container. I'm now going to come and uncomment the padding property. I'll refresh,
And you can see padding has been applied onto our flex item.
again giving the illusion like the content inside of it has been centered. So let's now continue our discussion by looking at vertically centering a container. For this to work, our parent container has to have a set height. Now, when we looked at horizontally centering a container, I stressed the idea that this works because the parent container does have a width, as block elements extend the full width of the page. Looking now vertically, if we don't set a height on our parent container, it means that the height of the parent container is being set by the height of the child container, which means that there's no space for our child container to move vertically. So looking first at how we can achieve this with box model, there actually is no easy way to vertically center a child container inside a parent container with a set height. So we have our browser, our parent container, our child container. Our parent container has a set height, and there is no easy way to vertically center the child container inside a parent container with a set height. So let's now look at Flexbox. Flexbox properties make it simple to vertically center flex items when the parent container has a set height. We would use align item center when the main axis is in row. If the main axis is in row, it means our cross axis is in column. And the cross axis is how we vertically center. And we know that align items is used on the cross axis. We would use justify content center if the main axis is in column. We know that justify content is used on the main axis. And if the main axis is in column, which is vertical, we would use justify content to center it. Looking at this in diagram form, we have our browser, our flex container, our flex item. Following on from the diagrams we've looked at before, we put our main axis in column, so it's going from top to bottom, which means our cross axis is going from left to right. As our flex container has a set height, we can easily use the justify content center property to center this along the main axis, which in this setup is responsible for vertical positioning, as our main axis is running from top to bottom. And just like we saw before, our flex properties are applied on the flex container. Now by doing this, the actual container is centered. It's not like we're using padding to create the illusion the child container is centered. It is actually centered inside the parent container. So let's go check this out in VS Code. Okay, so this is where we left off. I'm just going to go remove the padding for now. I'll refresh. And as I mentioned, for this to work, we need our parent container to have a set height, which needs to be more than the height of the child container, which is currently 300 pixels. So let's go give our parent container a height of 800 pixels. I'll refresh, and you can see now there is now vertical space for our flex item to move up and down. As we know, the flex direction is column, which means our main axis is running from top to bottom. So we're going to use the property justify content and set its value to center. And this centers our flex item vertically. It's also centered horizontally because before we had align items set to center. So this is a good example of centering a flex item both horizontally and vertically, using align item center and justify content center. And very importantly, for this to work, our parent container has to have a height bigger than the height of the child container, so there is space for the flex item to move vertically. We don't need a set width on the parent container, because for a block element like a div, it will extend the full width of the page, so it has a width. So let's now look at the final case of vertical centering content inside a container. This is used when the parent container has no set height. So before, our parent container had set height. Now our parent container doesn't have set height. Looking at the box model, padding can be applied to the top and bottom of the child container. So it's the exact same as the horizontal centering content inside a container we looked at earlier. But now we're just applying padding to the top and bottom. We would apply a property like padding with a top and bottom value set to 200 pixels and the left and right values set to 0. Looking at this in diagram form, we have our browser, our parent container, our child container, and because our top and bottom value of padding is 200 pixels, there's 200 pixels being applied above our child container and below our child container. Now you will note the child container is also centered horizontal, so there's also padding applied left and right. On the slides, I just want to focus on the padding applied top and bottom. And just like with horizontal padding, the padding property is applied on the child container. So let's go play around with this inside VS Code. So I'm going to go comment out our Flexbox properties, and I'm also going to comment out the height, as we want to be looking at a parent container which has no height. I'm now going to add back in our margin and padding properties from earlier. So I'll refresh, and we're back to the situation where our content has padding, giving the illusion that it's horizontally centered, and our entire content container has been centered inside the parent container. So all I'm going to do is change the 0 value here, which is currently controlling padding applied top and bottom, to now have a value of 200 pixels. I'll refresh, and you'll see our element now appears to be centered left and right and top and bottom. I'll open up DevTools. I'll select the child container, and you can see the child container in here with padding of 200 pixels all the way around. So let's now look at Flexbox. Now, because the parent container has no height, we can't use Flexbox properties like justify content and align items. But box model properties still apply on flex items, so padding can be used to create internal vertical space. So again, we'd apply a property like padding with the value of 200 pixels top and bottom and 0 left and right. In diagram form, we have our browser, our flex container, our flex item, our main axis is running from top to bottom, our cross axis from left to right, and by applying padding, we've effectively created internal space between the child container and the parent container of 200 pixels, both top and bottom. And the padding value is applied on the flex item. Now, both these methods is when content inside the container is centered. This is different to what we looked at before with vertical centering using align items and justify content, because in those cases, the actual container is being centered inside the parent. Using padding just creates internal space, effectively centering the content, and ultimately giving the illusion that the container has been centered. So let's play around with this inside VS Code. So I'm just going to comment out the box model properties, and I'm going to go uncomment the Flexbox properties. I'll refresh, and we're back to having our flex item horizontally centered. Just to build this up slowly again, let's go add padding of 0, top and bottom, and 200 pixels left and right. I'll refresh. This creates internal horizontal space left and right of our child container. Let's now go update the top and bottom value from 0 to 200 pixels. I'll refresh, and you'll see now that our child container appears to be centered vertically. Opening up DevTools, selecting the child container, I'll zoom out a bit, and you can see our child container now appears to be centered both horizontally and vertically. All right, that was a lot to take in. I'm sure you're feeling pretty overwhelmed with the different methods of centering available to us. So let's now go through each of them one by one and start gaining some centering guidance so we can get a better idea which methods are used where. To do this, I'm going to slowly start building up this table where I've got the columns of box model and flexbox next to each other. And for the rows, I'm going to be going through the 4 different cases we looked at. We'll first start with horizontally centering a container. This is when we're actually centering the child container horizontally within the parent container. With box model properties, we achieve that by applying a margin of 0 top and bottom and auto left and right, which centers the child container inside the parent container. This method is used to center main page containers and sometimes regular content containers. So let's now take a look at some examples of this by looking at horizontal centering guidance. Margin is often used to establish a web page's main container as it is a simple method for horizontal centering. Looking at this page here, as we know, our entire page is wrapped by a body tag in HTML. All the content we see on the page would be wrapped within a main container, which would often just be a div tag. To center the main container, we would use the margin property. So this is a common example of where we would use margin to horizontally center a child container. That is, the main container of a web page. Let's check out this page in DevTools. All right, so I'm going to go open up DevTools. And you can see over here, we have a div with the class hero container. I'll click it, and you can see in orange, left and right, that margin has been applied. Let's scroll down to the box model, where we can see currently a margin of 253 pixels has been applied left and right, which horizontally centers all the content within the page. If I scroll up, we can see margin left of auto and margin right of auto has been applied. This is the same thing as doing margin 0 top and bottom and auto left and right. They've just done it as two separate declarations. And just to show you that this is in fact centering all the content, if I turn them both off, you'll see all the content moves to the left. So using margin is a very common approach to horizontally centering your entire page. Now, using margin to horizontally center is also sometimes used for regular content containers. For example, on this page, we have our body tag, we have our main container, which we've seen is centered by using margin, but we can also use margin a second time inside the main container to center elements like this card. This card, which is a content container, would be inside something like a div, and the margin property is being applied both to the main container and to the content container. So let's go check this out. So I'm on this page, I'll open up DevTools. I'm going to select the main container over here. Going down to the box model, you can see it currently has a margin of 160 pixels left and right. And this establishes the main page container. That is, the wrapper around all the content on the page. If I go select this card, you'll see it too has margin applied left and right, effectively centering the entire card. And you can see the margin property over here is actually one of the uncommon ones used, where 4 rems has been applied to the top, auto has been applied left and right, and 2 rems has been applied on the bottom. So this is an example of using margin twice, on the main page container and also on a regular content container like a card. So let's now take a look at guidance on horizontally centering a container using Flexbox. As we've seen from the demonstrations earlier, depending on the orientation of the main axis, we can use Justify Content Center or Align Item Center. Flexbox is used to horizontally center regular content containers. Now, I know we just looked at centering a regular content container using margin, but using Flexbox is a lot more common, because Flexbox is a much more powerful way of handling alignment and spacing of items, which you just can't achieve with margin. So continuing on with our horizontal centering guidance, Flexbox properties make it simple to horizontally center regular content containers. Looking at this example, this hero section would be inside a Flex container. We have our Flex items, which are the heading, this paragraph text, and the 2 buttons.
Our main axis would be in column, going from top to bottom.
And our cross axis would be going left to right. Because our cross axis is horizontal, we would use the Align Items property to center our Flex items horizontally. So using Flexbox on regular content containers, like inside this hero section, is very common. Let's go check out this page. I'll open up DevTools. I'll select the container, which you can see is a Flexbox. You can see the flex direction is set to column, so our main axis is going top to bottom, and Align Items is set to center. I'll turn this off, and you can see some of our elements go to the left. So by applying Align Item Center, we're centering all of our Flex items horizontally. I'm going to scroll down the page to show you another example of where Flexbox is used on a regular content container. We saw this example earlier with these images. I'll open up DevTools, select the container. So you can see we have our Flex container. In this case, our main axis is going from left to right. So Justify Content Center is being used to center the image inside the Flex container. So long story short, Flexbox is a very common method used for centering items inside a regular container, and is much more commonly used than what we saw just before, where margin was used to center this regular content container. So continuing to add to our table, let's now look at horizontally centering content inside a container. To do this, we use the padding property, where we can set 0 for top and bottom and something like 200 pixels for left and right. This is used for creating equal horizontal space around content inside a container. Once again, the content is not actually centered, but extra space is now around the content, giving the illusion that it looks centered. And because box model properties work on Flex containers, this is both a method we can use on regular div containers and Flex containers. So padding is used to create equal internal space left and right around containers like cards and elements like anchor tags. Let's see this in action on this page here. This content, the heading, paragraph, and anchor tags, are all contained inside a div. It's a regular content container. Now, to create horizontal space around this content, padding has been applied. So it gives the illusion that this content has been centered. The same thing is happening with the buttons. I'll zoom in. We have our anchor tags, which are in red. And again, some horizontal padding has been applied to give the illusion that the content, the anchor tag, is being centered. So let's check this out in the browser. So I'll open up DevTools. Let's first look at this content container. You can see over here, it's just a regular div. There's no flex, so this isn't a flex container. It's a regular div. But you can see straight away all the green around it. I'll scroll down to the box model. You can see the content and the 64 pixel padding that's been applied left and right to create horizontal spacing. You can see the padding property here of 4 rems is being applied to all 4 sides. Let's go check out the anchor tag. Scrolling down to the box model, you can see the anchor tag over here in blue and the padding of 15 pixels left and right. Once again, the content has been centered, and because of the padding, it appears as if the anchor text has been centered left and right. So let's now look at how we can use padding inside Flexbox. Padding can be used to create equal internal space left and right on Flex containers. Looking at an example, we have all this content inside a Flex container, and because box model properties still apply, we can add padding left and right to give the illusion that this content has been centered. Let's go check this page out. I'll open up DevTools. I'll select the container. You can see over here the word flex. So this is a flex container. And you can see looking at box model properties, 60 pixels of padding has been applied left and right. So padding can be applied to regular div containers or flex containers. Again, giving the illusion that the content has been centered. So once again, we're not actually centering the content. We're just applying some padding to make it look centered. This is very different to what we looked at before, where in this flex container, we actually are centering the flex items using the align items property. So let's now start looking at centering guidance for vertical containers. We'll first be looking at vertically centering a container. If you recall, this is the case when our container had a set height on it. We saw that trying to use box model properties, there is no easy way to achieve this. With Flexbox, we can use justify content center or align item center, depending on the orientation of the main axis. And this method is used to vertically center regular content containers. So let's take a look in detail at the vertical centering guidance. Flexbox properties are often used to vertically center UI elements inside a Flex container that has a set height. Looking at this page, I'm going to zoom into the icons towards the left of the page. Looking at the middle icon, all of this content would be inside a Flex container. Our Flex item is the icon itself. The main axis is in row going from left to right, the cross axis in column going from top to bottom, and the container has a set height. This easily allows us to vertically center this icon using Flexbox properties. So let's check this out in the browser. So I'm going to open up DevTools. I'm going to select this Flex container. You can see Flexbox has been activated. And if I open up the div, you can see there's one Flex item, which is just the SVG, the icon. Looking at the container properties, because there's no Flex direction property set, it means our main axis is horizontal and our cross axis is vertical. This means that align item center is controlling the vertical alignment of our SVG. If I turn that off, you'll see the SVG moves to the top. So align items is vertically centering the Flex item, which is the icon, inside the Flex container. And the Flex container has a set height of 48 pixels. And if I hover over the icon, you can see it has a height of 25 pixels. This means that there's space for the icon to move up and down. This Flex item is actually being both horizontally and vertically centered. Justify Content Center is centering the Flex item horizontally. If I turn that off, you'll see it moves to the left. And turning Align Items off moves the Flex item to the top. So you can see when our container has a set height, it's very easy to vertically and horizontally center the Flex item with Flexbox properties. So let's now look at the last case, which is vertically centering content inside a container. For both box model and Flexbox, we use the padding property, where we would set a value like 200 pixels, top and bottom, and 0 left and right. This is used for creating equal vertical space around content inside a container. Now, just like horizontally centering content inside a container, We are once again adding internal space to give the illusion that the content has been centered. We're not actually centering the content or container, like we just saw with Flexbox properties justify content and align items. So padding is used to create equal internal space, top and bottom, around containers like cards and elements like anchor tags. Looking at the same page we looked at earlier when we spoke about horizontally centering content inside a container, we have our container around all the content, and padding has been applied top and bottom. If I zoom in on the anchor tags, the content is the anchor tag itself, and padding again has been applied top and bottom. So let's check out this page again in the browser. So I'm going to open up DevTools. I'm going to select the container. Once again, you can see it's a div. There is no flex, so it's just a regular content container. If I scroll down, you can see padding of 64 pixels has been applied top and bottom, as well as left and right. So it appears that this content is vertically centered, but in actual fact, we've just created internal space using padding. If I click the anchor tag, you can also see once again, padding has been applied top and bottom and left and right. So this is fairly common, applying padding to elements or containers, both horizontally and vertically, to create internal space to improve the visual aesthetic of the element or container. Now, padding can also be used to create equal internal space, top and bottom, on Flex containers. Looking at this page once again, we have our Flex container wrapping all the content, and padding has been applied top and bottom to create internal space to give the illusion that this regular content container has been centered. Looking at this inside the browser, let's open up DevTools. I'll select the container, which you can see is a Flex container, and scrolling down on the box model, you can see padding of 40 pixels has been applied top and bottom. And as we saw earlier in this example, padding of 60 pixels has been applied left and right. Once again, creating internal space to give the illusion that this regular content container has been centered. So let's wrap up by finishing off the summary card, Gap, Nested Flexbox, and Centering. In this chapter, we looked at centering. I'm going to be summarizing this all inside this table, where we have our methods for centering, box model and Flexbox, in the columns, and our rows are the different cases. Looking at horizontally centering container using the box model, we achieve this with margin, setting 0 top and bottom, and auto left and right. We have our browser, our parent container, and our child container, which is horizontally centered because of the auto value left and right. For Flexbox, we can use the Flexbox property justify content center. This would be used where inside our browser, we have a Flex container, our Flex item, our main axis in row running from left to right, and our cross axis going from top to bottom. Justify content with the value center is used in this case because our main axis is horizontal. If our main axis had been shifted so that it was in column, you would use align item center. Moving on to horizontal centering content inside a container, we would use padding, which set 0 top and bottom, and a value like 200 pixels left and right. We have our browser, our parent container, and our child container. Adding padding left and right creates internal space, giving the illusion that the content inside the container has been centered. And we saw this was commonly used on elements like cards and anchor tags. Because box model properties can apply on Flex containers and Flex children, we can do the exact same thing. Apply a padding like this. We have our browser, our Flex container, our Flex child. Again, our main axis is in row, and our cross axis is going top to bottom. Applying the padding creates internal space left and right on the child container, giving the illusion that the content inside the Flex item has been centered. Moving on to the next case, where we're vertically centering a container. And if you remember, this is when the parent had a set height. Using box model properties, there is no easy way to achieve this. With Flexbox, for our setup, where our main axis is in row and our cross axis is going from top to bottom, we would use the align item center property. We have our browser, our Flex container, which has a set height, and our Flex item will be centered. Our main axis running left to right, and our cross axis running top to bottom. And because align items is used for positioning Flex items along the cross axis, it's horizontally centered as the cross axis is vertical. The last case is vertically centering content inside a container. And this is commonly used when the parent has no height. On a standard container or element, we would apply padding like this, where a value like 200 pixels has been applied top and bottom. We have our browser, our parent container, and our child container, which has padding applied above and below, giving the illusion that the content inside the child container has been centered. We can also apply padding on a flex container or flex item. So we'd apply padding the same way we just did. We have our browser, our flex container, our flex item, where the main axis is in row, the column axis is top to bottom, and applying the padding would create internal space above and below the flex item, giving the illusion that the content inside the container is centered. Now, I know this was a lot to take in, but I do hope I have provided a comprehensive overview of how elements and containers are centered in CSS. So let's now go look at applying different centering methods on our Quill homepage. Earlier on in the course, in the box model topic, we already set up the main container using margin. We have our body tag in red, and we have a main container shown in blue containing all the content, and we're using margin to horizontally center this container. Let's check this out inside VS Code. So you can see in our CSS file, we have this container where we're using margin, 0, and auto left and right to horizontally center all our content. Let's check this out in DevTools. I'll select this div where the class container is being applied, scroll down to the box model, and you can see margin has been applied left and right with those orange lines horizontally centering our entire container. And as we saw in the guidance, this is a very common practice, using margin to horizontally center your main container. Let's now go see how we can use Flexbox in two other places on our page for centering. We're going to be using Flexbox on our hero section. We're going to be converting the entire hero section into a flex container. This flex container actually has a height set. We did this earlier in the units topic, where the hero section is using view height units, so it always appears above the fold in your browser. The flex items inside this flex container will be the heading, the paragraph, and the anchor tags. To ensure these flex items stack vertically, we need our main axis to run from top to bottom, that is, in column. We'll then use the justify content property to vertically center our flex items inside the flex container. Our cross axis is running from left to right, which means that we can use the align items property to horizontally center our flex items. So let's go do this inside VS Code. I'm going to scroll down to the hero section in our CSS file, and just a quick recap on the current setup of this. I'm going to open up DevTools, and I'm going to select the hero section. As I mentioned earlier, the hero section has a set height, which is 100 view height units minus the height of the navigation bar. If I scroll down in DevTools to the box model, you can see at the moment the height is 939 pixels. And if I reduce the height of my browser, the height of the hero section would reduce. Now the main takeaway point here is that our hero section does have height, which means that we can easily vertically center our flex items, which is the heading, the paragraph, and the grouped anchor tags inside this unordered list. So let's go to our hero section. Let's convert the entire hero section into a flex container. So we'll add display flex. I'll refresh, and you can see our flex items are now next to each other because the main axis is running from left to right. Let's shift the main axis so it goes from top to bottom. We'll grab flex direction and set its value to column. I'll refresh. You can see we're back to where we started, but this is now a flex container with flex items. Let's first vertically center our flex items using the justify content property. We're using justify content because our main axis is running from top to bottom. So we'll set justify content to center. I'll refresh, and now finally, our flex items are beautifully centered inside our hero section. Let's open up DevTools to check this. So you can see when I hover over the hero section, it's now a flex container, and the flex items are nicely vertically centered. So let's now go handle horizontally centering. Now, if you look at the page, it does look like it is horizontally centered, and that's being handled because we have text-align center applied on the hero section. Looking at our HTML markup here, because text-align center is applied on this parent, the hero section, the H1 and paragraph are effectively inheriting that property, so they're centering. The unordered list inherits text-align, the list inherits text-align, and because the list is acting as a parent container for our anchor tag, text-align is causing this anchor tag to center. We've seen this many times before in the course, where both block and inline elements will center when text-align is applied to a parent container. In this case, text-align is on the list item, which is the parent of the anchor tag. So because there's space to move, shown in blue above on the page, the anchor tag is able to center. So long story short, text-align, because it's applied on the hero section, is centering the text of block elements and is also centering inline elements. Now, I spoke earlier in this topic that we don't really want to be using text-align center as a method for centering things inside Flexbox. So for now, I'm just going to go comment it out, and you'll see our flex items now move to the left of the page. So let's go center them properly using the align items property and setting its value to center. I'll refresh, and you'll see they once again are centered, but this is using the correct method of Flexbox properties. Now, one thing you'll notice is our heading looks a bit weird now. That's because in our markup, in the hero section, we're using this BR tag to force digital world onto its own line. So if I select the heading, you can see the blue box is the heading element. And by default, if we use a line break tag, any new words will always be left align. So we actually do want to use text align center on this property to center any text in this heading. So heading back to app.css, I'm just going to copy this text align center. I'm going to remove it from the hero section. So I'll paste in the text align center. I'll uncomment it and refresh. So now our text for the heading has been centered again. Now you might be thinking, why didn't I just use text align center on the hero section and kept it how it was? This seemed like a lot of extra work just to get back to the same thing. Now that is not good practice. When we're using a flex container, we want to be using the Flexbox properties to handle spacing and alignment. Now the last thing I want to do here before we finish up the hero section is get these buttons next to each other. Looking at our HTML markup, these buttons are inside this unordered list. So we're now going to be using nested Flexbox, where this flex item, the unordered list, will become its own flex container. Let's first go add a class to this. We'll give it the class name hero btn container. I'll copy this. And then under the hero paragraph, let's go add this. We'll change its display property to flex. I'll refresh. And because this is now a flex container, our flex items, which are the two anchor tags, appear next to each other in row. Let's just go add some gap between them of 2 rems. I'll refresh. And now our anchor tags are next to each other with some space. And just to remind you once again of nested Flexbox, our hero section is the parent flex container. The H1 paragraph and unordered list are the flex items. We've now converted this flex item into its own flex container. And these list items, which hold our anchor tags, are the flex items of this flex container. So here's our parent container, and here's our nested flex container. All right, so I'm going to put the browser full screen so we can see our beautiful work. The top of our page is now complete. It's looking really, really nice, where we've used Flexbox on both the navigation and the hero section for all spacing. Scrolling down, we're going to be handling the layout of this section using CSS Grid in the next topic. Now, in principle, you could use Flexbox, where you could set each feature section to be its own flex container. But CSS Grid is a bit more purpose-built for the layout we want to achieve. I'm going to scroll down. We've also previously in this topic used Flexbox on our navigation bar and nested Flexbox to achieve the layout. Now, I want to finish off with the CTA card at the bottom here. Just as a reminder of how we're doing this. As we know, we have our main container centering all the content on the page. And in the box model topic, we actually centered the CTA card using the same method, where we're applying margin of 0 and auto. We actually saw a case of this in some of the guidance earlier. We have margin 0 auto on the main container, and then on a regular content container, centering it. Now, you can do this. This does work, but I would recommend inside the page using Flexbox as much as possible, because it's just a bit more powerful and a bit more versatile, and is the modern approach for handling layout on pages. So let's now go use Flexbox to center this CTA card instead of margin like we've done here. So we're going to be converting the entire CTA section into a flex container. We will then have one flex item where we currently have a div called CTA card wrapping our heading and anchor tag. Our main axis will be kept in row from left to right, which means our cross axis is running from top to bottom. And we'll then be using the justify content property to horizontally center our flex item. Now, just to note, there's also a lot of padding on the CTA card, which we'll talk about soon. But let's go use Flexbox to center this now. So I'm back inside VS Code. I first want to go recap on the HTML markup. Inside our CTA section, we have the semantic section tag with the class CTA section, and we have this div called CTA card holding the heading and anchor tag. So we're now going to go convert the CTA section into a flex container, which means the CTA card will be the single flex item. Looking at this in DevTools, you can see when I hover over the CTA section, there's space in blue left and right for our flex item, this div, to be centered. So jumping into app.css, let's scroll down to the CTA section. I'm first going to go remove the margin over here, as we don't want to use that anymore. On our CTA section, I'm then going to convert this into a flex container. I'll add display flex and use the justify content value and set it to center. I'll refresh and watch what happens. So our CTA card has been centered using Flexbox now. If I open up DevTools and select the CTA section, you can see those purple dashes and the space left and right where justify content is centering the entire CTA card inside the CTA section. Now, one thing you may have noticed when I did this is that the card actually reduced in width. Just to show you that again, I'm going to comment this out and add back the margin property here. I'll refresh and you can see the card expanded. Removing it and uncommenting this, I'll refresh and the card is reducing in width. So what is going on there? Just to confirm, we have achieved what we wanted. The card is centering, but there is some weird stuff going on with the width of the card when we move from margin to center the card to Flexbox. So to explain what's happening, I want to go add margin back onto our CTA card, and I'm just going to comment out the Flexbox properties. I'll refresh, and what's happening is that when you set margin like this, and we have a max width property at play, like we see here, the browser is using this max width of the CTA card to work out the available space to put left and right. Opening up DevTools, if I select the CTA card, you can see it currently has a width of 600 pixels. And when I add on the padding left and right, we get to 600 plus 200 plus 200, which is 1000 pixels. You can see the content inside the CTA card, get started now, and the anchor tag get started doesn't take up the full width of the box. That's because max width is working. There is space inside the actual content container, the div, created by the max width property. So in a nutshell, when using margin like this, the way the browser is calculating the available space to apply left and right is it is looking at this max width property and seeing what remaining space there is left and right to then apply. This is not how Flexbox calculates available space. I'm going to remove this, and I'm going to add back on our Flexbox properties. I'll refresh, and you'll see now our flex item, the CTA card, has a width of only 361 pixels. You can also see now that there is no more available space inside the CTA card content container. The heading Get Started Now butts up against the left and right of the box. It's a little bit hard to see because everything's in blue, but you can see when I hover over the content box, there is no more space left and right inside this blue box. So effectively, Flexbox is centering flex items based on the content width, not the maximum width. So that's why our card has reduced in width. In order to fix this, all we need to do is on our CTA card, add in the width property and give it a value of 100%, which effectively forces the CTA card to its maximum width. I'll refresh, and you'll see now the width of our CTA card is back to 600 pixels, and we have padding left and right of 200 pixels, so max width is being used as the width of the CTA card. So just be mindful of the differences of using margin and Flexbox and how the browser calculates available space when a max width property is involved. Now, the last thing I want to comment on is that we are using padding on our CTA card, both top and bottom and left and right, to center the content inside this container to give the illusion that the content is centered.
And we spoke about this method already at length throughout this chapter, where it is common to use padding to give the illusion that content is centered. Moving on, we'll learn how to control the behavior and sizing of individual flex items within a container by learning about the various properties for flex children.
We'll be discussing flex items properties, flex grow, flex shrink, align self, and order. So what are flex item properties about? Flexbox also has properties that control the behavior and positioning of flex items. Looking at our Flexbox diagram, we've seen many times by now, with the flex container, flex items, and main and cross axis. So far in this topic, we've looked at a whole range of properties that apply on the flex container. These include display with the value flex, flex direction, justify content, and line items and gap. And as you know by now, these are all applied on the flex container. But in Flexbox, there are also some properties that can be applied on individual flex items. These include flex basis, flex grow, flex shrink, align self, and order. And in this chapter, we're going to be going through each of these in detail. Now, just as an important note at this point, we will be looking at these properties in detail, and some of them may seem a little bit overwhelming. And I do just want to let you know that the flex container properties we've looked at so far are much more important and are way more commonly used in CSS. However, to complete this topic, you really do need to know about the flex items and how they work so that you can keep them in your back pocket if you need them. So let's start off by looking at flex grow. Flex grow determines how flex items expand to fill extra space in a container based on a set of proportions. The CSS property looks like this: flex-grow with a numerical value like 0. 0 is in fact the default value. That is, the value applied to all flex items if we didn't change the flex grow value. So let's look in diagram form how this works. We have our flex container, and let's say it has a width of 1,000 pixels. We have our flex items, and let's say each of them have a width of 100 pixels. The default behavior is that flex items do not expand to fill any available space in the flex container. So in this instance, horizontally inside the container, there's 600 pixels of available space, which is 1,000 pixels minus 4 lots of 100 pixels, giving us 600 pixels. So by default, the flex items stay as they are, and any available space will remain as available space. However, we can override this and use the flex grow property, and this calculates how flex items can fill the extra space. So let's see how this works, going through step by step. Items grow based on their flex grow value relative to the total. So let's start with box 1, which is the orange box on the far left. Let's give it a flex grow value of 1. For box 2, which is the second green box, let's give it a flex grow value of 2. For box 3, which is the third blue box, we'll give it a flex grow value of 0, which is just the default value. And for box 4, the fourth yellow box, let's also give it a flex grow value of 0, which again is the default value. So how this works is you would calculate the total flex grow, which is 1 plus 2 plus 0 plus 0, which is 3. So now any available space is distributed based on the flex grow value of a flex item relative to the total. So let's go see how this works. Box 1 effectively gets 1/3 of the remaining space. That is because the flex grow value of box 1 is 1 and the total is 3. So it gets 1 divided 3, or 1/3 of the remaining space. The remaining space is 600 pixels. So 1/3 of 600 pixels is 200 pixels. So our box 1, the orange box, will expand by 200 pixels. Which means that the new width of box 1 is its original width, which was 100 pixels plus 200 pixels, giving us a new width of 300 pixels. Now the remaining space has obviously reduced, but we need to keep our eye on the original remaining space when doing these calculations, which is 600 pixels. So let's now take a look at box 2. Box 2 gets 2/3 of the remaining space. And that's because the flex grow value is 2, the total flex grow is 3, so it gets 2/3 of the remaining space, which is 2/3 times 600 pixels, which is 400 pixels, which means that box 2 will grow by 400 pixels to a total width of 500 pixels. Looking at box 3, it gets 0/3 of the remaining space, and that's because its flex grow value is 0. 0/3 times 600 pixels of remaining space is just 0. So box 3 remains its width of 100 pixels. And the same thing happens for box 4. It gets 0/3 of the remaining space because its flex grow value is 0. So it remains at 100 pixels. So you can see how the flex grow value of 0 is just the default value, where by default, our flex items don't grow. So let's go play around with this inside VS Code.
All right, so I've gone ahead and just created a similar setup to what we just saw in the diagram before.
I have a div with the class flex container, and I have 4 flex items, where I've given each flex item the respective class flex item 1, 2, 3, and 4. And I've also just put the numbers 1, 2, 3, and 4 inside the flex items. In app.css, I've just given the body a color of white so we can easily see our numbers on our flex items, and a font size of 30 pixels. And we know this will be inherited by our flex items. For the flex container, I've given it a background color of light gray, a height of 500 pixels, and a width of 1,000 pixels. I've also applied the display flex property so that this is a flex container. For each flex item, they all have a width of 100 pixels and a height of 100 pixels, and different background colors, blue, purple, red, and green. So let's check this out in the browser. Okay, so nothing crazy going on. You can see our gray flex container and our 4 flex items. Because the flex container is 1000 pixels wide and each flex item is 100 pixels wide, the remaining space is 600 pixels. Let's open up DevTools, and you can see this purple hatched box is going to have a width of 600 pixels. And as you'll note, each flex item by default doesn't expand to fill this extra space. In the background, they all have a flex grow value of 0. If I set that on item 1 and refresh, you'll see there'll be no change. So let's now go set the flex grow values we did before. We had a flex grow value of 1 on flex item 1, a flex grow value of 2 on item 2, a flex grow value of 0 on item 3, and a flex grow value of 0 on item 4. Now, if you remember, the way flex grow works is it distributes available space onto our flex items. It does this by working out the total of the flex grow, which is 1 plus 2 plus 0 plus 0, which is 3, and then takes the flex grow value, divides it by that total, and multiplies it by the available space. So I'll refresh my browser, and you'll see now flex item 1 has a width of 300 pixels because it's getting 1/3 of the available space, which is 1/3 times 600 pixels, plus the original width of 100 pixels to give us a width of 300 pixels. And you can actually see inside DevTools, the original width has this hatched line, and you have this arrow showing how the flex item has grown by 200 pixels. Flex item 2 now has a total width of 500 pixels, which is 2/3 times 600 pixels, which is 400 pixels, plus the original width of 100 pixels. And flex item 3 and 4 have not grown at all because their flex grow value is 0, and 0 times 600 is 0, so no additional space is added onto flex item 3 or 4. So let's now move on to flex shrink. Flex shrink determines how flex items shrink relative to others in a container where there isn't enough space. So it's kind of the exact opposite of flex grow. The CSS property looks like this, flex-shrink, with a numerical value like 1, where 1 is actually the default value. So let's first take a look at what happens by default when the flex shrink value is 1. We have our flex container with the width of 1000 pixels. We have our 4 flex items, which each have a width of 300 pixels. So 4 times 300 pixels is a total of 1200 pixels, which means that these flex items won't fit inside the flex container. However, what's happening behind the scenes is that these flex items are actually forced inside the container. So their actual width will be 250 pixels. So each flex item has effectively reduced in width by 50 pixels. That's because the amount these flex items would have overflown would have been 200 pixels, and the 200 pixels is divided by 4 to give us 50 pixels. So each of these flex items shrink at the same proportion. And that's because behind the scenes, each flex item has a default value of flex shrink 1. So let's check out this default behavior in VS Code. So I'm back inside the file we were working on earlier. For each flex item, I'm now going to update its width to 300 pixels and remove the flex grow value. I've done it on flex item 1. Let's do it on flex item 2, 3, and 4. I'll refresh. And what you'll see is that we set a width of 300 pixels on our flex items. We have 4 of them, which means the total width of this should be 1200 pixels. And because our flex container has a width of 1000 pixels, we would expect there to be some overflow. If I open up DevTools and check this flex item here, you can see its width is 250 pixels, not 300. And you can actually see on the right, there's an arrow pointing left, showing how much it's shrunk by. Now, because by default, each flex shrink value is 1, so I'm just explicitly setting on flex item 1, but behind the scenes, this is currently set on flex item 2, 3, and 4. It means that each flex item will shrink by the same proportion. As I mentioned, the overflow value would be 1200 pixels minus 1000 pixels, so 200 pixels. That 200 pixels is then just distributed equally to each flex item to absorb that space. So effectively, each flex item reduces in width by 50 pixels, so its new width is 300 pixels minus 50 pixels, which is 250 pixels. We can see here. All right, I'm just going to remove this flex shrink value over there. So now let's see what happens when we change our flex shrink value to 0. We have our flex container with the width of 1000 pixels, and by setting flex shrink to 0 on each flex item means that we've effectively removed this default behavior of flex items shrinking to fit inside the container. So now our flex items will overflow. They will be the width we actually set them, which is 300 pixels, and there's overflow now of 200 pixels. So setting a flex shrink value of 0 means that your flex items don't shrink. Let's check this out in VS Code. So on each flex item, I'm going to add a flex shrink value of 0. And I'll copy this for each flex item. Okay, I'll refresh. I'll zoom out a bit. And you can now see that our flex items are extending beyond the flex container. You can see this hashed purple is the amount we're overflowing by. So let's now go see what happens when we apply different values to flex shrink. We'll be using the same setup we've just looked at. So items shrink based on their flex shrink value relative to the total. So this is kind of similar to flex grow, but it now has to do with shrinking. Let's look at box 1 to start. Let's give it a flex shrink value of 2. Box 2, let's give it a flex shrink value of 6. For box 3, let's give it a flex shrink value of 1, which is the default value. For box 4, let's also give it a flex shrink value of 1. So we now work out the total flex shrink, which is 2 plus 6 plus 1 plus 1, which equals 10. So what this means is that box 1 absorbs 0.2 of the overflow space. That is its own shrink value of 2 divided by the total 10, which is 0.2. The overflow space is 200 pixels. 0.2 times 200 pixels is 40 pixels. So box 1 is going to reduce by 40 pixels. So we have our flex container with the width of 1000 pixels, and box 1 now has a width of 260 pixels, which is 300 pixels minus 40 pixels. For box 2, it's going to absorb 0.6 of the overflow space. 0.6 is from box 2's shrink value of 6 divided the total 10. The overflow space is 200 pixels. 0.6 times 200 pixels is 120 pixels. So box 2 is going to reduce by 120 pixels, which means the new width of box 2 is 180 pixels. That is 300 pixels minus 120 pixels, which is 180 pixels. For box 3, it's going to absorb 0.1 of the overflow space. That is 0.1 times 200 pixels, which is 20 pixels. So the new width of box 3 will be 280 pixels. That is 300 pixels minus 20 pixels. And for box 4, it's the same thing. It absorbs 0.1 of the overflow space, which we know is 20 pixels. So box 4 will now have a width of 280 pixels. So let's go play around with this inside VS Code. So this is where we left off. I'm now going to go give the same flex shrink values we just saw. On flex item 1, that was 2. On flex item 2, that was 6. Flex item 3, it was 1. And flex item 4, that was 1. I'll refresh, and you'll see our flex items have now shrunk in proportion of each flex item's shrink value divided by the total, which in this case was 10. Looking at flex item 1, its new width is 260 pixels. Flex item 2, 180 pixels. Flex item 3, 280 pixels. And flex item 4, 280 pixels. And we just saw earlier how all these widths are calculated. So let's now move on to the next flex item property, which is align self. Align self sets individual flex items alignment by overriding the flex container's default align items value. So let's have a look at this. We have our standard setup of our flex container, flex items, and main and cross axis. So what align self allows us to do is align an individual flex item, like the one in green, along the cross axis. The CSS property looks like this: align-self, and a value like flex end. Let's say that this property is applied on the green flex item.
What this will effectively do is override any aligned items value, which we know is applied on the flex container to all flex items and results in aligning just that flex item.
So we'd end up looking like this, where just the green flex item is positioned flex end. Now currently, our flex items would have a property like align items flex start. That is, they're positioned at the start of the cross axis, but applying align self onto a flex item overrides this for a flex item. So let's check out all the values we can have for align self. The first value is align self auto, and this is just the default value. All this is saying is that if align items has a value, then the flex items will have that same value. Long story short, if you have an align items value, each flex item is just given that value by default, which makes sense. If there is no align items value on the flex container, and our flex items have a fixed height, it just means by default, our flex items will be at the start of the cross axis, like we see here. The next value is align self stretch, which when applied to a flex item, will stretch that flex item along the cross axis. The next value is flex start, which would position an individual flex item at the start of the cross axis. Now, if no flex items value is on our flex container, then we're not going to see any effect here. But if we did say have flex items set to flex end, we would then see our flex items at the bottom of the cross axis and a single flex item at the start of the cross axis. The next value is align self flex end, where we would now see a flex item at the end of the cross axis. The next value is align self center, which would position an individual flex item in the center of the cross axis. And to see the last value, I'm going to add the align items value flex end and apply align self baseline. So what we'd end up with is this. We're applying align items flex end, so all our flex items would be at the end of the cross axis, but then an individual flex item would be positioned baseline. That is, it's positioned on the baseline of its own text, like this. So let's go play around with these inside VS Code. Alright, so I'm back in the file we were working in earlier. For each flex item, I'm just going to go remove the flex shrink value and give it a width of 200 pixels. I'll do this with flex item 1, flex item 2, flex item 3, and flex item 4. So I'll refresh my browser, and our flex items are now back inside our flex container. Now let's quickly recap the setup we have. Our main axis is in row going from left to right, and our cross axis is going from top to bottom. Because our flex items have a fixed height of 100 pixels, it means that by default, they're just going to be at the top of the flex container. So let's go and apply some align self properties. I'll be doing this all for flex item 2. Let's go apply align self and set its value to auto. I'll refresh, and you'll see nothing happens. This is just taking the align self value set on the flex container, which is not set, so it's just taking the default value of putting it at the start. If I change the flex container's align items value to something like flex end, all our flex items move to the end of the cross axis. And again, align self auto is effectively just applying flex end onto flex item 2. It's just taking whatever value is being applied on the flex container. I'm actually just going to leave the align items value as flex end now, as it will help me better demonstrate the other properties. Let's change auto to the next value we looked at, which was stretch. I'll refresh, and align self is stretching. Well, it isn't really, but what's happening is that because this has a fixed height, the flex item is unable to stretch, and if that's the case, it'll just move to the top of the flex container. If I comment out the height for a second and refresh, you'll see that the flex item does in fact stretch. Alright, I'm going to uncomment this, and let's look at the next value, which is flex start. I'll refresh, and now flex 2 is actually at the start of the cross axis. The next value is flex end. I'll refresh, and this is just moving it in the same position as all the other flex items set here. To see the impact of this, let's change this to flex start. I'll refresh, and you can see all our flex items are at the top, where flex item 2 is now at the bottom. Alright, I'm just going to put this back to flex end. The next value we looked at was center, and this will center this flex item along the cross axis. And for the last value, baseline, to better demonstrate this, I'm going to remove the height on flex item 2, and I'm going to give it a font size of 50 pixels. Let's update the align self to baseline. I'll refresh, and what's happening is that this flex item is positioned according to the baseline of itself, which is just under the 2 here.
So as I mentioned at the start of the chapter,
this can all seem overwhelming, learning all of these new align self values. I really wouldn't worry too much about it. As I've mentioned, aligning flex items on the container with justify content and align items is way more common to do. So let's finally take a look at the last flex item property, which is order. Order changes the visual order of flex items independent of their order in the HTML markup. The CSS property looks like this, order with a numerical value, where 0 is the default value for all flex items. So let's take a look at how this works. We have our flex container and our flex items, where we can see 0 is the default values for all of them. So the way the orange, green, blue, and yellow box are appearing is just the order they appear in the HTML. What we can do is override the order of the flex items no matter what the HTML is. Looking at an example, so what we could do is on our third flex item, the blue box, we could set a value of -1. This would make it come first. Let's leave the green and yellow box, that is the second and fourth box, as 0. So they'll appear like this. The green box first, followed by the yellow box. That is because the green box appears first in the HTML markup before the yellow box. And then we can apply a value of 1 to the first box, which will now be the last flex item. So the order number is moving us from lower order numbers to higher order numbers. And once again, we're completely overriding the position of the flex item as it appears in the HTML. So let's go play around with this inside VS Code. So I've picked up where we left off. I'm just going to go remove this align self value, remove the font size, and uncomment the height. I'll refresh, and let's go play around with order. Let's have our third flex item now appear first. I'll put an order there of -1. For flex item 2 and 4, I'm just going to leave those alone, which means by default, the order value is 0 for 2 and 4. For flex item 1, let's make that come last. So I'm going to go give it an order of 1. I'll refresh, and you can see flex item 3 is now first, as it has the lowest order value. 2 and 4 have an order of 0, so they appear here. And flex item 1 has the highest order value of 1. Now I could change this to something massive like 99. It doesn't matter. It's just looking at the numbers moving from left to right. And I don't have to use negative numbers to maintain this order. I could change this to 1. Flex item 2 is in position 2. So let's give it an order of 2. Flex item 4 is in position 3. So let's give it an order of 3. And flex item 1 is in position 4. So let's give it an order of 4. I'll refresh and you'll see there's no change, as we're moving from 1 to 2 to 3 to 4. The reason I used negative numbers earlier, it's because it allows me not to then put order values on some of the flex items. So sometimes it can be more efficient using negative values and relying on the default value for some of your flex items. So let's wrap up this chapter by building the next summary card, Flex Children. We looked at several Flex Children properties. The first was Flex Grow, which was about how flex items can grow to fill extra space. We looked at an example with a flex container and 4 flex items with equal width. We can also see there's extra space inside the flex container. And by default, the flex items won't expand to fill the extra space. But we can override this using the Flex Grow property. We set a Flex Grow value of 1 on box 1, a Flex Grow value of 2 on box 2, a Flex Grow value of 0 on box 3, and 0 is the default value, meaning it won't grow, and also a Flex Grow value of 0 on box 4. The way it works is the total Flex Grow value is calculated, which is 1 plus 2 plus 0 plus 0,
which equals 3.
The flex items will then fill the extra space like this, where the first flex item gets 1/3 of the extra space. That is its own Flex Grow value, 1 divided by the total, 3. The second flex item gets 2/3 of the extra space, which is its own Flex Grow value of 2, divided by the total of 3. And because box 3 and box 4 both have a Flex Grow value of 0, they won't absorb any extra space, so they remain the same size as they originally were. We then looked at Flex Shrink. This is about how flex items shrink where there isn't space. We looked at an example with the flex container. We saw that by default, the flex shrink value was 1, which means that flex items will by default shrink within the container in the same proportion of any overflow. We saw that we could set the flex shrink value to 0, which would then result in our flex items overflowing, like this. Flex shrink was then the proportion of how each flex item absorbs this overflow space in order to fit inside the container. On the first box, we set a flex shrink value of 2. On the second box, we set a flex shrink value of 6. On the third box, a flex shrink value of 1, which is just the default value. And on box 4, we also set a flex shrink value of 1, which again is the default value. The way flex shrink works is the total flex shrink is calculated, which is 2 plus 6 plus 1 plus 1, which equals 10. And this results in our flex items all fitting within the container like this, where the first box absorbs 0.2 of the overflow space, that is its own flex shrink value of 2 divided by the total of 10. The second box absorbs 0.6 of the overflow space, that is its own flex shrink value of 6 divided by the total of 10. Box 3 then absorbs 0.1 of the overflow space by the same logic, and box 4 also absorbs 0.1 of the overflow space, the exact same as box 3. We then looked at the align self property, which sets individual flex item alignment along the cross-axis, and will override any align items value set on the flex container.
The first value we looked at was align self auto,
which is just the default value, and just takes whatever the value is set for align items. The next value was align self stretch, where you can see the green box has stretched, and this would only work if the green box does not have a set height, but is just content, like some text. We saw align self flex start. To better show this, I've set the align items value to flex end, which means all our flex items will be at the end of the cross-axis, and you can see the green box is at the start of the cross-axis. The next value was align self flex end, and you can see the green box is at the end of the cross-axis. The next value was align self center, where you can see the green box is centered along the cross-axis. And the final value was align self baseline, where when your flex item has some text, it will align according to the baseline of its own text. The last property we looked at was order. This was where we could override the order of our flex items as they appear in the HTML. The property looked like this: order with a numerical value, where 0 is the default. We could then do something like this, where we have a flex item with the order value of -1, the next flex item, the order value 0, the next flex item, the order value 1, and the last flex item with an order value of 2. So the flex items are being ordered from lower value to higher value. And again, this completely overrides the order they appear in the HTML.
In the final chapter, we'll explore how to handle items that don't fit in a row and control their alignment using flex wrap and align content.
We'll be discussing flex items shrinking behavior, flex wrap property, align content property, and align content values. So let's first quickly recap the shrinking behavior of flex items. If flex items are larger than their container, by default, they will shrink to fit inside. We saw this in the previous chapter, where we have a flex shrink value of 1, which is the default value. What this results in is inside our flex container, which let's say is 1000 pixels, our flex items will shrink to fit inside this container. So let's say these flex items are 300 pixels wide. That would mean that the total width of these flex items is 1200 pixels, so we should expect to see overflow. But what's happening is that behind the scenes, our flex items have a flex shrink value of 1, which means that each flex item is absorbing the overflow space. So that 200 pixels is effectively divided by 4, so each flex item will absorb 50 pixels. So the width of the flex items will be 250 pixels. We saw that we could set a flex shrink value of 0, which effectively removes the shrinking behavior. So we end up with our container of 1000 pixels, but now our flex items will be their actual width of 300 pixels, and you can see we now overflow the container. So let's again check this out in VS Code. So I've got a very similar setup to what we saw in the previous chapter. I have a flex container with 4 flex items. Inside app.css, we have our body, where we're applying the color white to our text and a font size of 30 pixels. Our flex container has a background color of light gray, a height of 500 pixels, a width of 1000 pixels, and the display property is set to flex, so that each of our flex items are now in a row. Each flex item is 300 pixels by 100 pixels, and each have a different background color. So the first thing I want to do is just open up DevTools. I'll select our flex item, and you can see in the box model, its actual width is 250 pixels. If I go hover over it, if you remember, we also have that arrow on the right, visually showing how the flex item is shrunk. I'm going to go change the flex shrink value on each flex item to 0 to effectively remove the shrinking behavior. And I'm going to apply this on each of our flex items. I'll refresh, and you can see our flex items now do overflow the container. So when we have this situation of flex items overflowing the flex container, there is something else we can do here, and that's using flex wrap. Flex wrap pushes flex items onto multiple lines instead of being forced to fit on a single line when they exceed the container. The CSS property looks like this, where flex-wrap is the property, and in this case, wrap is the value. It's important to note that flex wrap is set on the flex container. The values we can use include no wrap, wrap, and wrap reverse, where no wrap is the default value. So flex wrap can be used in the specific case when your flex items exceed the container. Like in the demonstration I just showed you in VS Code, that would be an opportunity to use FlexWrap. Now FlexWrap works a bit differently if there is height or no height set on the parent container. Let's look at a general block container first. That is, when our flex container has no set height. The way FlexWrap works here is that our flex items will appear next to each other, and to fit the flex item that is going to wrap onto the next line, the flex container expands. Looking now at a flex container with a set height, like this one here, when the flex items wrap, there's actually a line dividing the flex container in two, so the rows divide equally. Our flex items will appear as usual, and then the flex item which we're wrapping onto the next row will appear at the start of the divided row. Let's go play around with this inside VS Code. So I'm back inside the file we were working on earlier. Let's go first look at the case when there is no set height on the flex container. I'm just going to go comment this out and refresh. So what this means now is that our flex items are setting the height of the container. And the container in light gray is now hidden because our flex items go beyond the width of the flex container. Now I'm just going to go remove the flex shrink values as we no longer need those anymore. I just did that before to demonstrate that our flex items can overflow, but by default, the flex shrink value of 1 applied behind the scenes to each flex item ensures that they fit within the container. I'll refresh. So now our flex items are back to 250 pixels wide, all within the flex container. Now this is a setup where we can use FlexWrap. And once again, that's because our flex items, when added up, will overflow. If our flex items fitted within the container, FlexWrap simply wouldn't work. It only works when your flex items can extend beyond the flex container. So let's go add our FlexWrap property. I'm first going to set the default value of no wrap. I'll refresh and you'll see there's no change. And that's because by default, our flex items won't wrap. Let's change the value now to wrap. I'll refresh and you'll see the flex item, which would have been overflowing, now wraps onto its own line. And the container has expanded in height to allow this flex item onto its own row. Let's go apply the other value of wrap reverse. I'll refresh. And as you can see, this effectively flips our different rows. All right, I'm just going to comment this out for now. Let's now go look at the other case by adding our height back in. I'll refresh. And again, we can see that our flex items are shrinking inside the flex container. Let's go wrap these. I'll uncomment this. And let's just use the value wrap. I'll refresh. And now you can see that when we have a set height, the height is divided by 2, and the flex item that was overflowing now appears at the start of this row. So just be mindful of how wrap works when there's height or no height set on the flex container. And really just to drive this point home, this property only works in a situation where your flex items do exceed the width of the container. So just to show you this, if I go and update all the flex item widths to 200 pixels, if I sum these up now, 4 times 200 is 800 pixels, which is less than the total width of the container of 1000 pixels. We still have our FlexWrap property applied, so if I refresh, you'll see they don't wrap onto another line. And that's because this only works when the sum of the width of your flex items exceeds the width of the container. Now, when we do have our flex items wrapping onto a new line, there is an additional property that allows us to control the alignment of the wrapped flex items. We do this with the align content property. Do not get this confused with align items, where align items is used to space and align properties along the cross-axis. Align content controls the alignment of flex items along the cross-axis when there are multiple rows of flex items. I really want to highlight, it's when there are multiple rows of flex items. So you can only use align content when you apply FlexWrap and your flex items are on multiple rows. In CSS, it looks like this, where align-content is the property, and FlexStart is an example of a value. Also really importantly, align content is set on the flex container. So let's have a look at the setup of this. We have our flex container. In this example, I'm looking at one with a fixed height. We have our flex items, which are wrapping onto different rows. We have our main axis and our cross axis. So align content is the alignment of flex items on the cross axis when there are multiple rows of flex items. That is, when we are applying FlexWrap. Let's look now at all the different align content values. The first value is align content stretch, which is just the default value. In our setup, our flex items will essentially stretch their entire height. The next value is flex start, where our flex items are all at the start of the cross axis and butt up against each other vertically like this. The next value is flex end, where our flex items are now at the end of the cross axis. The next value is center, where our flex items wrap in the center along the cross axis. The next value is space between, where our flex items have maximum space between them. And the last value is space around, where our flex items have equal space around them. So let's go play around with these inside VS Code. Alright, so I'm back inside the file we were working on earlier. I also just went and changed the width back to 300 pixels so that our flex items wrap. Let's go add the align content property, and I'm going to set the value to its default value of stretch. I'll refresh and you'll see nothing happens. Now what's actually happening is that because our flex items have a fixed height, they actually can't stretch. So they just end up looking like this, where the rows divide by 2 and they are just their height. What I'm going to do to better demonstrate the align content property is just turn off the height of each flex item and let the height be determined by the height of each number in each flex item. So I'll refresh and you can now see that our flex items do stretch the height of their rows. Let's go play with all the different values. We'll do flex start. I'll refresh and you can see our flex items all start at the start of the cross axis. Let's do flex end. I'll refresh and you can see our flex items move to the end of the cross axis. The next value we looked at was center. I'll refresh and our flex items now appear in the center. The next value was space between. I'll refresh and you'll see this creates the maximum space between our rows of flex items. The last value we saw was space around. So let's update this. Opening up DevTools, there's now equal space top and bottom of the rows of flex items. So the space above here and below here, and the space above here and below here are all equal. Now I just want to quickly highlight that the align content property can only be used when we have flex wrap enabled. I'm going to comment out flex wrap. I'll refresh and you can see the align content property is doing absolutely nothing. I'm going to add this back on and refresh. Now I also just want to show you that align items still does work. If I go align items and set the value to say flex start, I'll refresh and you can see our flex items are now at the start of the cross axis. However, as soon as I add back in an align content value like space around, I'll refresh, you'll see that the align content value completely overrides the align items value. As a general rule of thumb, you should be using align content when flex wrap is enabled, and align items for most cases when your flex items are inside the flex container. Now I know this can be really intimidating and confusing with align content, align items. My general word of advice is don't really worry too much about flex wrap and align content. The majority of layouts you're going to be working with are just a regular flex container where you're going to be using the align items value that we've been using throughout this topic. So let's now take a look at some flex wrap guidance. As I've kind of mentioned, I wouldn't worry too much about flex wrap as it's not often required. But let's look at some cases where you could use it. Wrapping is useful for simple linear layouts when elements need to wrap onto multiple lines. Taking a look at an example of this, we have this page over here with these logos showcasing where this application has been seen in the media. When you reduce the width of the browser, these logos wrap onto 2 different rows. So let's go check out an example of this in the browser. On this page here, when I scroll down, you can see company logos that are using this application. Let's go open up DevTools. I'll select the flex container over here. You can see it's going across 2 rows, which is being controlled by this flex wrap property here. If I turn the flex wrap property off, you can see they all go inside the flex container. Now the reason I wouldn't worry too much about flex wrap is that the truth is, when we start thinking about layouts like this, which are 2-dimensional, that is, they contain rows and columns, this is actually a grid layout. And we're going to be spending a lot of time in the next topic talking about this. Just to give you a taster, you can see a very similar layout here to what we saw before of rows and columns. That is a 2-dimensional grid layout. If I go inspect this layout, you can see over here the word grid. So that's why I wouldn't really worry too much about flex wrap. When layouts need both rows and columns, grid is the way to go, and we're going to be spending a lot of time in the next topic going through this.
So let's finish up by building our next summary card, flex wrap and align content. We first looked at flex wrap, which is when flex items wrap onto multiple lines if they exceed the container. In CSS, it looked like this, where the values include no wrap, wrap, and wrap reverse, where no wrap is the default value. We then looked at 2 different cases, The first is the flex container with no height. We saw that the flex items set the height of the container, and as the flex item wraps onto another line, the container expands. We then looked at a container with a set height, and in this case, the container is split into two, where rows divide equally, and our flex items are placed at the top of each row. We then looked at align content. Align content dealt with flex alignment along the cross-axis when there are multiple rows. We looked at all the values, including align content stretch, which is just the default value, and in diagram form, our flex items just stretch the full width of their row. Align content flex start is when our flex items go to the start of the flex container along the cross-axis. Align content flex end is when our flex items go to the end of the flex container along the cross-axis. Align content center is when our flex items center along the cross-axis. Align content space between is when space is created between our flex items, such that the top row of flex items touches the top of the flex container, and the bottom flex items touch the bottom of the container. And the final value was space around, which creates space between the rows of flex items and between the rows and the edge of the flex container. That's Flexbox ticked off the list. Well done. Learning layout techniques can be challenging, but you've made fantastic progress. Let's now take our layouts to the next level by mastering CSS Grid. CSS Grid is a powerful two-dimensional layout system that allows us to build complex designs with ease. In this topic, we'll explore how to structure web pages using rows, columns, and different grid alignment techniques to take full control of our layouts. Let's begin by exploring a powerful two-dimensional layout system with an introduction to CSS Grid. We'll be discussing what is CSS Grid, CSS Grid terminology, CSS Grid design guidance, and CSS Grid versus Flexbox. So what is CSS Grid? CSS Grid is a two-dimensional layout model, making it simple to arrange items in rows and columns. Now, the key difference between Flexbox and CSS Grid is that CSS Grid is two-dimensional, and it has rows and columns. Looking at an example of CSS Grid, on this page, you can see we have a 2x2 grid, and there are a total of 4 grid cells. We can see the first one here, the second one here, the third one here, and the fourth one here. This is an example of a two-dimensional layout which has rows and columns, where CSS Grid is used to achieve this. So let's start looking at some CSS Grid terminology. CSS Grid has two main components. We first have the grid container, which is the parent, and this is similar to the flex container in Flexbox. And then we have grid items, which are the children, and this is similar to flex items in Flexbox. So just like Flexbox has two main components of flex container and flex items, in CSS Grid, we have grid container and grid items. CSS Grid has two axes, and very different to Flexbox, we can't change the direction of the axes. The vertical axis is known as the column axis, and the horizontal axis is known as the row axis. The grid is divided into grid cells by grid lines. You can see vertically and horizontally, we have grid lines. And these grid lines divide our grid into grid cells. Now we actually number these grid lines like this. I'm going to start with our vertical grid lines at the top left. We would label the first one 1, then 2, then 3, then 4, and then 5. These numbers are very important for some properties we're going to be looking at later. Now we just numbered our vertical grid lines going from left to right. But you can also number them from right to left using negative numbers. Pay attention to the bottom right now. That is, on grid line 5, this is also -1. Moving to the left, we have -2, -3, -4, and -5. Let's now go number our horizontal grid lines. Paying attention to the top left, we're going to label the first horizontal grid line 1, then 2, and then 3. And now moving your attention to the bottom right, we're going to do the same thing with negative numbers, starting at -1, moving up to -2, and then -3. Now, as I mentioned, these grid lines define grid cells, which are shown in blue over here. So we can see our grid cell. Now, what's really important to note from the outset is that a grid item, which I've shown in green, isn't always the same size as a grid cell. You can see in my diagram, there's actually space inside the grid cell. And in fact, we're going to see later on, using some CSS Grid properties, we can move our grid item, that is the green box, inside the grid cell. And in fact, grid cells can have no grid items. So for example, the bottom left cell might not even have a grid item inside of it. So it's really important from the outset to distinguish between a grid cell, which is defined by grid lines, and a grid item, which is an actual piece of content. And some grid cells can be empty. That is, there is no content inside the grid cell. Now, grid lines define grid tracks. Grid tracks is just a fancy word for rows and columns. We can see our grid rows over here, where we effectively have 2 rows, a row over here, and a row over here. Looking now at our grid columns, we have 4 of these over here. 1, 2, 3, and 4. Grid rows and columns can have spacing between them. So you just saw our grid container expand vertically and horizontally. We still have our horizontal grid lines and our same grid rows in yellow, but now we have some space between our grid rows. Labeling our grid lines, we have horizontal grid line 1, grid line 2, where there is now space between the grid lines, which we call horizontal gap. And then we have grid line number 3 on the edge of the grid container. Looking now at our vertical grid lines, we again have our grid columns shown in purple, and let's go label our vertical grid lines. We have grid line 1 on the edge of the grid container. Grid line 2 now has some vertical gap. Grid line 3 also has some vertical gap. Grid line 4 also has vertical gap. And grid line 5 is on the edge of the grid container. So let's have a look at CSS Grid on a web page. I'm on this page where you can see these cards are arranged in a grid, which has 2 rows and 3 columns. Let's open up DevTools, and if I select the main container, you can see CSS Grid is being applied. You can see our vertical and horizontal grid lines, which are defining our grid cells, which have inside of them content, which are the grid items. You can also see there's horizontal and vertical gap between the grid cells. So this is just one example of how you could use CSS Grid, and we're going to see many implementations of CSS Grid throughout this topic. So let's now take a look at how we can activate CSS Grid by using Display Grid. The display property on a container element will activate grid layout features on children elements. It's the exact same with Flexbox. We use the display property with the value grid. And just like Flexbox, the display property is declared on the grid container, the parent. Looking at values for display, we have block, inline, inline block, flex, and grid. So by the end of this topic, you'll know how to use each of these values, as we've already covered block, inline, inline block, and flex at great length in this course. So let's go play around with this inside VS Code. Alright, so I've gone ahead and created a new index.html file, which just has the boilerplate, and I've linked up an app.css style sheet, which is currently empty. Inside index.html, I'm going to go create a div. I'm going to give it the class grid container, which as the name suggests, means this div will be our grid container. I'm then going to go add 8 grid children by adding 8 divs. I'm just going to pop the number 1 in the first div and give it a class of grid item 1. For the second div, I'll copy this class, pop it here, and change it to grid item 2 and give it the number 2. Now to avoid boring you, I'm just going to repeat this pattern for all 8 divs. Alright, so we now have our 8 grid items inside our grid container. Let's now move over to app.css. I'm first going to grab the universal selector and just remove all default margin and padding. I'm going to grab our grid container and I'm just going to give it a font size of 40 pixels. This means our grid items will inherit this font size as it's being defined on the parent. We'll make the grid container into a grid by adding the display property with the value grid. We'll grab grid item 1, and I'm just going to give it a background color of red. I'll copy this style, change it to grid item 2, and give it a background color of green. Now again, to avoid boring you, I'm going to go add colors to the other grid items. So we have our 8 grid items, all with different background colors. So let's go check this out in the browser. Alright, so you can see our grid over here. By default, you'll see straight away that a grid just has one column, where our grid items are being stacked vertically on top of each other. We can confirm grid has been activated by opening up DevTools, selecting the grid container. You can see the word grid here, and you can also see the horizontal grid lines, which are those dashed purple lines. Now if I go comment out display grid and refresh,
you'll see there's actually no visual change. But this layout is not a grid. You can see inside DevTools, there's no grid appearing here, and there are no grid lines. We don't have those purple dashed lines. I'll just uncomment this again. I'll refresh, and you can see now our grid is back on with the grid lines reappearing. Now, throughout this topic, we're going to be using this setup to look at all the different properties for CSS Grid. But I do just want to highlight that by default, our grid items just appear in a single column. And we'll be seeing in the next chapter how we can use grid properties to get the two-dimensional layout of rows and columns. So let's now take a look at some CSS Grid guidance. CSS Grid can be used for complex two-dimensional layouts. Looking at this page over here, if we were to see the grid, it would actually look like this. This is a very complex two-dimensional layout, where we have elements like text spanning grid cells. That is, our text is actually going across different grid cells. And you can see over here, we have images also spanning cells. So for this design, to achieve this interesting effect of images and text in a complex 2D layout, CSS Grid has to be used. Grid is also commonly used for major sections. This page has a very popular kind of layout, which would often be used for a feature section, with columns of alternating images and grouped text. You can see our 4 grid items over here. Grid is also commonly used for UI elements with consistent spacing in a one-dimensional row or column. Now, you could also use Flexbox for this, and we are going to be seeing soon when to use Flexbox and when to use Grid. So here's what I mean. You can see these 3 cards are in a one-dimensional layout, but using Grid is actually fairly common. And we're going to see soon it's because we can easily divide a grid container into columns like this, where in this example, 3 columns are being used. So even though this is a one-dimensional layout, CSS Grid is being used with a single row and 3 columns. And this is actually a fairly common implementation. But of course, you can still use Flexbox. And if you were to look at DevTools at a layout like this, you'll see some pages use Flexbox and some pages use Grid. So it's kind of down to what you prefer. So when you're starting out, it can be quite confusing when to know to use Grid or Flexbox. So let's take a look at CSS Grid versus Flexbox and get a general idea of when you'd use each. Looking at Flexbox first, Flexbox is generally used for smaller UI. In CSS, we know it's defined like this, and it's a one-dimensional layout model in rows or columns. Examples of where we'd use Flexbox include navigation bars, footers, components, which would include things like buttons, text callouts, and inside cards. Flexbox is also used on hero sections and forms. These are good examples of one-dimensional layouts which tend to be smaller pieces of UI. Looking now at Grid, as a rule of thumb, this is used on larger UI. We know it's defined like this, and CSS Grid is a two-dimensional layout model with rows and columns. Common places we'd see CSS Grid is in complex 2D layouts, like we saw earlier, with the images and text spanning different grid cells. It's also commonly used in large feature sections, where we saw an example of alternating images and group text in rows going down the page, and also used in cards, which could be in 2 dimensions or even in 1 dimension, like we just saw earlier. So as a general rule of thumb, Flexbox is used on smaller UI and Grid is used on larger UI. And there are some cases where there is a bit of overlap where you could use Grid or Flexbox, just like those one-dimensional cards we looked at before. So let's wrap up this chapter by starting to build out the next summary card, CSS Grid Fundamentals. In this chapter, we looked at grid terminology. We saw that a grid has a grid container. Inside the grid container are our grid items. From top to bottom, we have our column axis, and from left to right, we have our row axis. And we discussed how these do not shift like in Flexbox. We then have our vertical grid lines, which are numbered from left to right 1, 2, 3, 4, and 5. And going the other way, we can also number them with negative numbers. Starting at the bottom right, we have -1, -2, -3, -4, and -5. We then have our horizontal grid lines. Looking in the top left, we number them 1, 2, and 3. And now looking in the bottom right, with the negative numbers, we go -1, -2, and -3. These are our grid lines. Our grid lines define our grid cells. And we also spoke about how a grid cell doesn't always have to have a grid item inside of it. And a grid item can also be smaller than a grid cell.
And we're going to see later on some properties which allow us to align grid items inside of grid cells. Focusing on our grid container and our grid cells, we then spoke about grid tracks, which were defined by our grid lines, where we can have a grid row shown here and another grid row here. We then have a grid column defined by our vertical grid lines, which we can see here. And in this setup, we have this grid column here, here, and here. Between our grid rows and grid columns, we can have space. First looking horizontally, we call this horizontal gap, which is space between our grid rows. We can also have space between our grid columns, which we call vertical gap, and looks like this. Next, we'll learn how to structure layouts by defining tracks with grid columns and rows. We'll be talking about grid template columns and rows, the fractional unit, the repeat function, and grid column and row design guidance. So let's start off talking about grid columns and rows. Grid items will appear in a single column by default. We saw this in the previous chapter when we were playing around with CSS Grid. We added the display grid property. This defined a grid container, and we saw that all our grid items appeared by default in a single column, stacked one above another. The height of the grid container is the sum of the grid items. And because our grid items, we know the block element will extend the full width of the page or the container there inside. So this is our default setup. By adding display grid to a container, all children are converted to grid items, which by default will appear in a single column. So let's now look at how we can define columns in CSS with grid template columns. This is a CSS property that sets the number of columns and width of each. The property looks like this: grid-template-columns. And the values we use define the width of each column. So 100 pixels is the width of column 1, and 200 pixels is the width of column 2. So these two values are defining the width of the columns. Let's go play around with this inside VS Code. Alright, so I'm back inside the file we were playing around with in the previous chapter. We have our 8 grid items defined inside this grid container, which we previously put the display grid property on, converting this into a grid. And as I mentioned earlier, our grid items will just stack vertically by default in a single column. So let's go add the grid template columns onto our grid container. Let's make 2 columns, the first 100 pixels and the second column 200 pixels. I'll refresh and you'll see now that our grid has 2 columns. Let's open up DevTools. I'll select the grid container. Let's check out grid item 1, which is in the first column. So you can see from the box model, it has a width of 100 pixels. If I click on grid item 2, you can see it has a width of 200 pixels. The other thing I want you to note is that when I click on the grid container, you can see the purple dashed lines are defining the grid. So let's now take a look at grid template rows. This sets the number of rows and height of each. The CSS property looks like this: grid-template-rows. And similar to grid template columns, the values are now setting the height of each row. So row 1 will be 50 pixels, row 2 will be 100 pixels, row 3 is 200 pixels, and row 4 is 300 pixels. So each of these values are setting the height of each row. Let's go play around with this inside VS Code. Alright, so I'm back inside our file, and at the moment, the height of each row is just being defined by the height of the content itself. You'll also note that there are 4 rows, and this is happening because we earlier defined 2 columns. And because there are 8 grid items, it means that 2 grid items will appear per row. So that's why we end up with 4 rows. It's a result of having 8 grid items in 2 columns. But let's now go explicitly define our rows. We'll grab the grid template rows property. Let's still define 4 rows. The first row will set as 50 pixels, second row 100 pixels, third row 200 pixels, and fourth row 300 pixels. I'll refresh, and you can now see that the height of our rows is being explicitly defined by grid template rows. Now, as I mentioned earlier, when we didn't have the grid template rows property, we had 4 rows, and that was a result of having 8 grid items in 2 rows. But what I can do with the grid template rows property is also explicitly define the number of rows I want. So for example, let's go remove 300 pixels and just define 3 rows. I'll refresh. So now what's happening is that I'm explicitly defining only the first 3 rows, and grid items 7 and 8 are still in our grid container, but will just be their default height. Now in the earlier chapter, I mentioned that you can have grid cells which don't necessarily have to have grid items inside of them. So let me show you how we can end up in that situation. I'm going to come to our grid template columns and add an additional column of 300 pixels. So what this means is we now have 3 columns and 3 rows, and we only have 8 grid items. So let's see what happens when I refresh.
You can see in our last row and last column, we have a grid cell with no grid item in them. And that's because we've defined 3 columns and 3 rows, which means that there's 9 cells. But we only have 8 grid items, so the last cell is empty. Let's check this out in DevTools. I'll select the grid container. And you can see in the bottom right, we have a grid cell with no grid item inside of it. You can also now see our grid lines appearing with the numbers we saw in the previous chapter. Alright, so we now have a good idea of how to define columns and rows in our grid. It's now time to talk about a special unit called the fractional unit, which we haven't seen before and is very commonly used in CSS Grid. The fractional unit defines the fraction of available space in the grid container, and we use it like this, where we have our property, like grid template columns, and we define our columns using this fractional unit. Or in this case, I've defined 3 columns. The first is 1FR, the second is 3FR, and the third column is 4FR. So this is how it works. We have our grid container, which let's say has a width of 1000 pixels. We then add up our total fractions, which would be 1 plus 3 plus 4, which equals 8. We then take our width of 1000 pixels and divide it by our total fractions of 8, which gives us a value of 125 pixels. So we end up slicing our grid container into 8 fractions, each with 125 pixels. So essentially, one fraction is equal to 125 pixels. We then look back at the grid template columns values we decided. Our first column is 1 fractional unit, which we know is 125 pixels. Our second column is 3 fractional units, which would be 3 lots of 125 pixels. So that's 375 pixels. And our third column is 4 fractional units, which is 4 lots of 125 pixels, which is 500 pixels. So fractional units is an easy way to define our grid columns proportionally. Let's go play around with this inside VS Code. So I'm back inside the file we were working on earlier. I'm just going to go remove our grid template rows property and just go back to 2 columns we had before. So let's go use the fractional unit to define our columns. I'll remove the pixel values. Let's define our first column as 1 fractional unit and our second column as 3 fractional units. So let's open up DevTools so we can talk a bit more about what's happened. So if I select our grid container, now because our grid container is just a div, it will just extend the full width of the browser. Now by using fractional units, we're effectively dividing this space into 4, that is 1FR plus 3FR, and then our first column is 1/4, that is 1 fractional unit on the total of 4 in width, and our second column is 3 divided by 4, which is 3/4. So we've effectively divided our grid container into 2 columns, where the first column is 1/4 the width of the entire page, and the second column is 3/4 the width of the entire page. Now one thing I want to show you, that this is technically the same thing as using percentages. I could change this to 25% and change this to 75%. I'll refresh and you'll see there is no change. However, it's much more common to use fractional units when defining grid columns and rows. So I'm just going to change those back. Now the last thing I want to show you is that at the moment, our grid container has no width. It's just extending the full width of the page. Let's now go set a width of our grid container of 400 pixels. I'll refresh, and now the fractional units are dividing the width of 400 pixels to define our columns. So the first column is 1/4 of 400 pixels, which is 100 pixels, and our second column is 3/4 of 400 pixels, which is 300 pixels. So I just wanted to show you that fractional units will define your columns proportionally based on the width, and that width could be the full width of the page if it's just a general block container, or it could be the width explicitly defined on the grid container. So let's now take a look at fractional units and rows. Now fractional units and rows are just a little bit more tricky, and the behavior hugely depends on whether the grid container has a set height or not. So let's look at the first case. If height is set on a grid container, FR units proportionally distribute space to the grid items. This behavior is very expected. It's the exact same as what we saw with columns, just being applied to rows. So we have our CSS property, grid template rows, and we're defining 3 rows. The first one has 1 fractional unit, the second row 2 fractional units, and the third row also has 2 fractional units. Looking at this in diagram form, we have our grid container. Let's say its height is 1000 pixels. The total fractions is 1 plus 2 plus 2, which equals 5. So our grid container has 5 fractions, each with a height of 200 pixels. That is 1000 pixels, the height of the container, divided by 5, the total number of fractions, to give us 200 pixels. So these define our fractions of rows. Looking at grid template rows now, our first row we defined to have 1 fractional unit, so will look like this, with a height of 1 fractional unit. Our second row is 2 fractional units, which would be 400 pixels. And our third row is also 2 fractional units, and also will have a height of 400 pixels. So let's go check this out in VS Code. So the first thing I want to do, just so we can look at the case I just went through, is I'm going to go add an explicit height on our grid container of 1000 pixels. Let's then go grab our grid template rows property, and let's define 4 rows. The first will be 1 fractional unit, the second 2 fractional units, the third 3 fractional units, and the fourth 4 fractional units. Let's refresh, and I'm going to zoom out quite a bit to see what's going on. So if we add up all our fractional units, 1 plus 2 plus 3 plus 4 gives us 10 fractions. Because the height of our grid container is 1000 pixels, it means that each fraction will be 1000 pixels divided by the total fractions of 10, giving us one fraction equal to 100 pixels. So our first grid row, which is 1 fractional unit, will be 100 pixels. Our second grid row, which is 2 fractional units, will be 200 pixels. Our third row, 300 pixels, and our fourth row, 400 pixels. So let's continue our discussion with fractional units and rows, and look at the other case, which is if no height is set on the grid container, FR units use the height of the grid items to set height and space on the grid container. This is very unexpected, where the fractional units are being calculated by the height of the grid items. They're no longer dividing the height or width of the grid container. So let's see what this looks like. Let's say we define our rows like this, grid template rows, which will define 3 rows, row 1 of 1 fractional unit, row 2 of 3 fractional units, and row 3 of 4 fractional units. Looking in diagram form, we have our grid container, and let's say each grid item is 10 pixels. Now, as there's no height set on the grid container, the height of the grid container is the sum of the content, that is 30 pixels. Let's now move back to our fractional units. We'd calculate the total fractions, which would be 1 plus 3 plus 4, which equals 8. And what this now does is define 8 fractional units like this. We're no longer dividing the grid container in 8, but we're basing the fractional units on the height of the grid items. So we could then calculate what the new total height of our grid container will look like, which equals 10 pixels times 1 fractional unit, plus 10 pixels times 3 fractional units, plus 10 pixels times 4 fractional units, which equals 80 pixels. So this means the height of our grid container will be 80 pixels, where the grid container has now scaled based on the grid items. And our grid rows will now look like this. The first row is 1 fractional unit, which is 1 divided by 8, the total fractions, multiplied by 80 pixels, which would be 10 pixels. The second row, which is 3 fractional units, is 3 divided 8 times by 80 pixels, that is 3 fractions of 10 pixels. And our third row is 4 fractional units, which is 4 divided 8 times 80 pixels, which is 40 pixels. So this is just really strange behavior, where our grid container is actually expanding based on the height of our grid items and the different fractional units we're using. Now, this may seem incredibly overwhelming, and honestly, I wouldn't worry about it too much. We're going to see soon in the guidance that in most cases, we don't even use grid template rows, let alone grid template rows when there is no height on a grid container. Most of the time, we're just using grid template columns to define our columns, and the rows are just a result of the number of columns and grid items, where we don't actually go and explicitly define our grid rows. And I'll cover that in more detail soon, but I wanted to bring it up now because I imagine you're feeling very overwhelmed. And I seriously wouldn't worry too much about this. As always, I do just want to show you so you know everything that's going on, but honestly, don't stress too much about it. Alright, so let's check this out in VS Code. What I'm going to go do is now remove the height on our grid container. I'm just going to temporarily comment out our grid template rows. I'll refresh, and we're now back to a grid container of 400 pixels with our columns defined with 1 fractional unit and 3 fractional units. Okay, so our grid container has no set height, which means the height is being set by the height of our grid items. So the sum of these 4 grid items are setting the height. I'm going to uncomment this and refresh, and you'll see how our grid container has now expanded. So let's open up DevTools. You can see the height of this grid item is 46 pixels. Now, because our first row is 1FR, that means that 1FR is equal to 46 pixels. Now, if I add up our fractional units of 1 plus 2 plus 3 plus 4, that gives us 10 fractions. As 1 fractional unit is 46 pixels, it means our height of our grid container is now being set at 46 pixels times 10 fractional units, which gives us a height of 460 pixels, which you can see here when I click on grid container. And then each grid row is now defined by a multiple of our fractional unit, which is 46 pixels. If I click on grid item 3 in row 2, you can see it has a height of 92 pixels, 2 times 46 pixels. If I click on grid item 5 in row 3, its height of 138 pixels is 3 times 46 pixels. And grid item 7 in row number 4 has a height of 184 pixels, which is 4 times 46 pixels. So once again, just to summarize this, when you don't explicitly have a height on your grid container and you're using fractional units, the fractional units are calculated based off the height of the grid items. And as I mentioned earlier, I really wouldn't worry too much about this, but I do just want you to see how it works. So let's now take a look at the repeat function. The repeat function is a helpful tool which can be used to repeat rows or column dimensions when they are recurring. It looks like this, where we have our grid template columns or rows property, and we use this function called repeat. Inside the repeat function, we have 2 values. The first value is the number of rows or columns we wish to define, in this case 4 columns, and the second value is the size value, that is, the size we want our columns to be, in this case 1 fractional unit. So what this will give us is a grid with 4 columns, each 1 fractional unit in width. So it's just a cleaner way of defining 4 grid columns, each with the same width. You can of course define this as grid template columns, 1FR, 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 that is 1FR 4 times, but this function is just a nicer and cleaner way of defining it. So let's check this out in VS Code. So I'm back inside the file we've been working on. I'm going to go just remove grid template rows. At the moment, we have 2 columns. Let's go define 4 columns, each with 1 fractional unit. So the long way of doing it is like this, using 1FR 4 times. I'll refresh, and this defines us a grid with 4 columns, each 1 fractional unit. The width of our grid container is 400 pixels, so that means that each column will be 100 pixels. That is 1 divided by 4, where 4 is the total number of fractions, multiplied by the width. So instead of doing this, we can define it like this. Repeat. The first value is the number of columns we want, which is 4, and the second value is the width of our columns, which we're going to define as 1 fractional unit. I'll refresh, and you can see we end up with the same thing. Now you don't have to use fractions here, you can use other units. So let's say I define this as 200 pixels. I'll refresh, and you can now see that we have 4 columns, each 200 pixels wide. Alright, let's finally take a look at some column and row guidance. So the good news is the actual use of rows and columns is fairly simple in practice. Columns are often set with FR units, and the width of the grid container is usually not set, but extends the width of the page. Looking at this page as an example, we have 6 grid items here, which would all be defined in this grid container, where the grid container extends the full width of the page. We have the 6 grid items shown in green, and we have 3 columns, all with equal width, and would each have 1 fractional unit, which very simply defines 3 columns with equal width, each taking up 1/3 of the grid container. Now the number of rows are not usually set, but are automatically defined by the number of grid items. I touched on this earlier when you were likely freaking out about using grid template rows. As you can see here, the good news is we often don't even use it. We just define grid template columns and let the number of rows automatically fall into place by knowing our number of grid items and the number of columns we're defining. In this case, we have 3 columns with 6 grid items,
which automatically creates our 2x3 grid.
And finally, the height of the grid container is not usually set, but defined by the sum of the height of the grid items. As we've seen throughout this course, when defining page sections or components, it's very common not to actually set height, but let the height be automatically determined by the height of the content. So the height of the grid container is the sum of the height of the content in the grid items. So our grid items contain things like images and text and anchor tags. So the height of each grid item would be the sum of those, and the height of the grid container would be the sum of the grid items. So let's wrap up this chapter by adding to our summary card CSS Grid Fundamentals. In this chapter, we looked at rows and columns. We saw how we could define columns with the CSS property Grid Template Columns, and we also looked at fractional units, which are very commonly used in CSS Grid. For Grid Template Rows, the CSS property looked like this, where we also saw we could use a repeat function, where the first value is the number of rows, And the second value, in this case, would be the height of each row of 200 pixels. These properties would then define our grid, which would look something like this, where we have two columns, where the width of the first column would be 1/3 the width of the grid container, the second column would be 2/3 the width of the grid container, and for the rows, we would have two rows, each with 200 pixels in height. And just as a final reminder, don't freak out too much about the use of grid template rows. We're mainly going to be using grid template columns and fractional units to define our grid and let our rows be automatically calculated. So let's now go ahead and start adding a grid to our Quill homepage. This section of the page, which has our features, will be defined inside a grid. We'll define a grid container, where the grid container width extends the full width of the page. We then have our grid items, which are either grouped text or an image. In our layout, we want two columns of equal width. So we will be using fractional units to define our columns, where each column will be one fractional unit. This will effectively divide our grid container to have two columns of equal width. Now, because we have two columns with 6 grid items, this automatically creates a 3x2 grid. That is, a grid with 3 rows and 2 columns. Let's add on our vertical grid lines and our horizontal grid lines. Now, one thing I want you to notice is that our text grid items have a different height to our images. So the height of the grid container is set by the height of the images. That's because in each row, the image has a larger height compared to the grouped text. So the image grid item is setting the height of each row, which means that the height of the entire grid container will be the sum of the heights of the images. Now, later on in this topic, we're going to be talking about alignment of grid items when there's extra space in the grid cell. So you can see, for example, our group text has been vertically centered inside each grid cell, and we're going to be looking later at how we can do that. Now, before we jump into VS Code, I do just want to point something out. This layout of alternating text and image as you move down the page is very common, and there are actually 2 ways of achieving this. The method we're doing is defining a grid for the entire section. Let me show you this on another page. Okay, I'm going to scroll down to the features section of this page, and you can see we have these alternating images and group text as we scroll down. I'm just going to zoom out quite a bit. I'm going to open up DevTools, and you can see we have a single grid defining this entire section. Now I want to contrast this to the implementation on this page. I'm going to scroll down, and you can see we have the same layout, where we have alternating text and image. I'm also going to zoom out quite a lot. I'm going to open up DevTools, and let's go select the grid. And what you'll notice is that each row is actually its own grid. We have a grid here, we have a separate grid here, if I scroll down, and we have a separate grid here. So I just wanted to show you this is another common way of implementing this. Now I've decided to go with this method, but do be aware this is another common implementation of defining separate grids for each row. So I'm back inside our index.html file for our Quill project. I'm going to scroll down to the features section. And before we start using the CSS grid properties, we need to make some adjustments to our HTML. So at the moment, inside our section, we have our 3 features, each defined inside a div. Here's feature 1 with the heading, paragraph, and image. Feature 2, heading, paragraph, image. And feature 3 with the heading, paragraph, and image. So the first thing I want to do is just go define our grid container. I'm going to grab a new set of divs, and I'm going to give this the class of features grid container. Now, if I were to just copy and paste these divs for each feature back inside of here, this isn't going to work with the layout we want. And that's because inside our grid container, we would just have 3 grid items. This one here, and this one here. And what we need is 6 grid items, where we need to group our text for some of the grid items and just use the image as the other grid items. So what I'm going to do is I'm going to get another div, and this will be used to group our text. I'll copy this and place it inside the div. So now we have our grid container with our first grid item, the grouped heading and paragraph inside this grid item, this div here. And the next grid item is just the image. I'll copy that and paste it over here. And I just need to repeat this same structure for the other feature sections. So I'll define another div for our group text for feature 2. I'll copy this and paste it here. I'll then grab the image for feature 2 and paste it here. Finally, I'll get the last group text from feature 3 over here. I'll copy that and paste it here. And then finally, I'll grab the image from feature 3. So this now gives us our grid container with 6 grid items. Grid item 1, which is the group text for feature 1. grid item 2, which is the image for feature 1, grid item 3, which is the grouped text for feature 2, grid item 4, which is the image for feature 2, grid item 5, which is the grouped text for feature 3, and grid item 6, which is the image for feature 3. So let's now go remove the original markup. Now I really don't want these divs over here to throw you off. The div here is just a child of our grid container, no different to the image. So that's why the entire div is the grid item, where inside the div we have some text. So once again, we have 6 grid items. This one here, 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 and this one here. Heading over to app.css, let's go down to our features section over here, and under the features main heading, I'm going to go grab our features grid container. We'll change the display property to grid, and let's go define our grid template columns. And as we said, we're going to define 2 columns, each with a width of 1 fractional unit. Now I've defined it like this. You could also use the repeat function, but because this is 2 columns, I'm just going to use this implementation. So let's check this out in the browser. Now before I refresh, this is what the page originally looked like, where we have our feature section with text and image repeated. Now in our markup, we've now grouped this text, so that's 1 grid item, and our image is another grid item. So I'll refresh, and you'll now see we have 2 columns where our grid items is group text and an image, and each column is 1 fractional unit. Let's open up DevTools. I'll select this div with the class features grid container. I'll zoom out a bit, and you can see our grid in all its glory, where inside each grid cell, we either have group text or the image. And as I mentioned earlier, the height of this grid container is being defined by the height of each image. You'll also notice that inside each grid cell, there's actually some space for our content to move. In the grid cells with our text, you can see there's some vertical space here. And in the grid cells with our image, you can see there's horizontal space. And we're going to soon be learning about grid alignment properties that allow us to move grid items inside grid cells when there is space. The other thing I want to mention is that in our final design, the text and images alternate as you move down. You can see that's not happening here, where in the second row, we want the image on the left and the text on the right. Now, one way of fixing this is going to the underlying HTML and changing the order of the second feature. I could take this image and put it above the group text for feature 2. I'll refresh and you'll see this corrects this. However, this is not a good implementation. Let me just change it back. There's actually 2 reasons why it's not a good implementation. The first is we want to keep our HTML markup consistent, where we first have our group text and then image for each feature. This is much cleaner and much more consistent. The second reason, which is more important, is that when we come to the next topic and learn about media queries and responsive design, it's going to make it a lot easier having our flex items defined like this. So we'll see why this is a lot better. So to correct this, we are going to learn about a property later on, which allows us to manually define the position of a grid item.
Now it's time to learn about how to create spacing between grid items using grid gap.
We'll be discussing default spacing between grid items, the gap property, and gap design guidance. So let's first talk about the default spacing between grid items. By default, grid items are placed next to each other with no spacing between them. Looking at an example grid, we have our grid container, and we have our different grid items. In this case, a grid which is 2 rows by 3 columns. And you'll notice by default, there is no spacing between any of the grid items. They butt up right next to each other. Let's take a look at this inside VS Code. So this is the file we were working on in the previous chapter. I want to go update it to just have 2 columns. So I'm going to do 1FR and 1FR. I'll refresh, and we're now back to having 4 rows and 2 columns. I'm going to zoom in a bit, and as you can see, our grid items all butt up right next to each other. There is no spacing between them. If I open up DevTools and select the grid container, you can see those dashed grid lines, which act as a border between the grid items. So by default, there is no spacing between our grid items. Now this is a fairly simple example, and I actually want us to get more familiar with thinking about grid cells as opposed to grid items when it comes to spacing. So to better understand what I mean, I've gone ahead and prepared this file ahead of time. I've got a simple div, which I've given the class grid container, and I have 8 images inside. In app.css, I've gone ahead and removed margin and padding, and on the grid container, I've converted this into a grid. I've given it 2 equal columns of 1FR and 1FR, and I've given the entire grid a width of 1000 pixels. So let's check this out in the browser. So you can see I have 8 different images of my favorite satirical character Borat, each with different sizes. You can see they're in a grid with 2 columns and 4 rows. Let's open up DevTools, and you can see the grid here with the grid lines. Now the reason I want to get more comfortable with thinking about grid cells as opposed to grid items is that when we're talking about gap, we're talking about space between rows and columns, which is space between our grid cells. So you can see, for example, inside this grid, this image, which is a grid item, is inside this top left grid cell. And you can see that there's space inside that grid cell for this grid item to move. We'll be looking at how we do that in the next chapter. But what I really want you to get comfortable with is that the spacing we're going to be looking at now is between grid cells, not grid items. It can be that your grid item is the same size as your grid cell, like in the simple example we looked at earlier, but that's not always the case. So I just wanted to make a note about that from the outset, that the spacing in this chapter we're talking about is spacing between our grid cells. So for the rest of this chapter, I'm no longer going to be talking about grid items, but rather grid cells. So let's now take a look at the gap property. The gap property creates space between grid rows and columns. Here's our flex container. In blue, we now have our grid cells, and we can use the property row-gap, which will create space between our rows. And in this case, the space will be 20 pixels. And we can also use the CSS property column-gap to create space between our grid columns. In this case, a space value of 40 pixels. So let's play around with this inside VS Code. Alright, so I'm back in the file we were working on earlier. Now the first thing I want to do before we go add some gap is look at the size of our grid cells. If I click on this grid cell, you can see it's currently 200 pixels wide by 46 pixels high. Let's now go add some row gap of 20 pixels. I'll refresh. You can see now that between our rows, there's 20 pixels of gap. Now because there was no height set on this grid container, to account for the additional 20 pixels between each row, the entire grid container has effectively expanded. And you can see the height of our grid items are unchanged. They're still 46 pixels high. I also want you to notice that in the CSS grid model in DevTools, our grid line, like this one here, number 3, now actually appears as 20 pixels wide, whereas grid line 1 is just in one dimension. It has no width. I'm going to exit DevTools just so you can clearly see the row gap of 20 pixels between each row. I'm going to open up DevTools again and select the grid container. Now let's go add column gap. And this time, I want you to keep an eye on the width of our grid cells, which are currently 200 pixels wide. This is being set by the width of the grid of 400 pixels. And because there's 2 columns, each with 1 fractional unit, it results in the columns being 200 pixels wide. So let's go add some column gap of 40 pixels. I'll refresh, and you can now see we have 40 pixels of column gap. But the big thing you'll notice here is that the width of the cell has actually reduced. It was 200 pixels and has now gone to 180 pixels. So what this means is that if you have a set dimension on either width or height, if you add column or row gap, it will reduce the width or height of the content. Now in most cases, you won't have a height set, so your grid container will just expand in height, whereas with width, you'll either have a width set, like 400 pixels, or it will just expand the full width of the page. So to show you this, let me turn this off. I'm going to comment out column gap. I'll refresh. Our grid items are currently 310 pixels wide. Let's go add our column gap back in. I'll refresh, and you'll now see, to account for the additional column gap of 40 pixels, our grid items have reduced to 290 pixels. So long story short, in most cases, when it comes to the width of a grid container, it will either be explicitly set, or it will just extend the full width of the page. And in both those cases, adding column gap will reduce the width of your grid item. Now with height, in most cases, you will not set an explicit height on the grid container, which means that when you add row gap, the height of your grid container will just expand to account for the additional space between your rows. Now once again, I really want to stress that the row and column gap we've just looked at is spacing between grid cells. So I'm back in our Borat collage. Just going to open up DevTools. Let's go add row gap of 50 pixels and column gap of 100 pixels. I'll refresh. I'll select the grid container, and I want you to once again see that the spacing is between our grid cells, and it's our grid cells that make up columns and rows. So for example, the spacing is not the spacing between this flex item and this flex item. It's the spacing between this entire grid cell and this grid cell. And as I mentioned earlier, we're going to be looking at the next chapter at how we can move our grid items inside grid cells when there is space like this inside the grid cell. Now, the other thing I just want to note before we move on is that row gap and column gap is not created on the perimeter. So for example, in this grid, you can see there's no column gap on the far left and on the far right. It's only down here. And the same for row gap. There's no row gap right at the top and right at the bottom. It's only between our actual rows. Now, another version of the gap property you can use is the simple property gap with a value like 40 pixels. And this value is the value for the row and column gap set in one go. So for example, in our grid container, we have our grid cells. Our row gap is 40 pixels, and our column gap is also 40 pixels. So if you're using an equal value for both row and column, you can simply use the gap property. So let's now take a look at some gap guidance. Gap is commonly used to space grid items in major sections. We can see over here a typical feature section with alternating images and group text. I'm going to lay over the grid cells. We can see over here some large row gap, and over here some smaller column gap. Gap is also commonly used for spacing in card layouts, such as testimonials and features. Looking at this example here, we have our grid cells.
We have row gap and column gap.
So there are many instances where you do want to be using gap inside your grid layout. So let's now finish off the summary card, CSS Grid Fundamentals. In this chapter, we looked at gap. We saw the CSS property row-gap and the CSS property column-gap. We saw that these properties create gap between our grid cells. For row gap, the value is 40 pixels. That is 40 pixels between our rows inside our grid. And for column gap, the value is 20 pixels. That is 20 pixels between our columns inside our grid container. We also looked at the gap property, which sets a gap value for both rows and columns at the same time. So in this example, a gap of 20 pixels will set 20 pixels of space between our rows and 20 pixels of space between our columns. So let's now go and apply column and row gap to our Quill homepage. So far, we've established a grid container with our grid cells in a 3x2 layout. We're going to go ahead and add some row gap between our rows and some column gap between our column. So let's jump into VS Code and add this to our project. So I'm back inside our app.css file for the Quill homepage. Now before we go add some values, I want you to see that our rows are really quite on top of each other. We really do want to create quite a bit of space between each of these rows to improve the visual aesthetic. We're also going to add a small value of column gap to just spread these out a bit more. Now, ordinarily, you'd go play around with values until you feel like the page looks right. I played around before, and for me, a row gap of 15 rem, which in our project is 150 pixels, and a column gap of 5 rem, which is 50 pixels, look good for me. I'm going to refresh, and you can see this creates more vertical spacing between our different features, which just seems a bit more consistent with the layout we have. And as I mentioned, I just think this spacing looks good. But you, of course, can go add whatever spacing you like. Now, just to see the row and column gap in action, let's open up DevTools. I'll select the grid container, and you can see the column and row gap with the purple dashes. Now, the other thing I just want to mention before we finish up is that the values I picked here, 15 rem and 5 rem, are still part of our spacing system we defined much earlier. 5 rem is equivalent to 50 pixels, and 15 rem is equivalent to 150 pixels. So whatever values we pick for our spacing should still fall in line with the spacing system we established earlier on in the course.
Moving on, we'll explore how to position content within individual grid cells using grid alignment.
We'll be discussing the Justify Items property, the Align Items property, and grid cell alignment design guidance. So what is grid cell alignment? This is where grid items can be aligned inside grid cells if there is space available. So let's take a look at this on this page here. We have our grid container and our 2 grid items. I'm going to add in our horizontal grid lines and our vertical grid lines. You can see that the height of the grid is set by the height of the image. This means that on the left, there's space inside the grid cell, as the grouped text, which would be inside a div, is not the same height as the image on the right. So there's space above and below for this grid item to move inside the grid cell. So let's check out the first property, Justify Items. Just a note, this is not Justify Content, which we saw in Flexbox. Justify Items aligns grid items inside a grid cell along the row axis. The CSS property looks like this, where at the moment the value start is being used. Looking at this in diagram form,
We have our grid container, our vertical grid lines, and horizontal grid lines. The grid lines define our grid cells, and inside the grid cells, we have our grid items. So you can see in this setup, there's space for our grid items to move inside the grid cell along the row axis. So this is where we could use justify items to align the grid items. Now there are 4 possible values we can use. The first value is justify item start, which we just looked at earlier, and it will align our grid items at the start of each cell along the row axis. The next value is justify items end. We have our grid container, and along the row axis, our grid items are at the end of each grid cell. The next value, justify item center. We have our grid container, and along the row axis, our grid items are in the center of their grid cell. And the final value is justify item stretch. And this is in fact the default value. We have our grid container, and along the row axis, our grid items are stretching the full width. So let's play around with this inside VS Code. So I'm back inside the app.css file we were playing around with in the previous chapter. So let's go add our justify items property to see it in action. Like all the other properties we've seen so far, justify items is set on the grid container. And the first value I want to use is the default value stretch. I'll refresh and you see nothing changes. And that's because the grid item is being stretched inside the grid cell. You can see the number 1 only takes up this width of content. And because I've added a background color, you can see the background color has been fully stretched inside the grid cell. Let's go look at the other values. We saw start. I'll refresh, and you can see the grid item is now only occupying its actual width and is at the start of the grid cell. Let's check this out in DevTools. You can see our grid container with the grid lines now appearing, and you can see inside each grid cell, the content, which is just the number 1 inside a div with some background color, is at the start of the grid cell. The next value we looked at was end. I'll refresh, and you can see the grid item now moves to the end of the grid cell along the row axis. And the final value we looked at was center. I'll refresh, and this now centers our grid item inside the grid cell along the row axis. So now let's take a look at the align items property. This property is the same as what we're using in Flexbox. Now by now, I'm sure you're getting a bit overwhelmed with the different alignment properties flying around, where some are used on Flexbox, some are used on Grid, some are not. In the next chapter, I'm going to be doing a side-by-side comparison of the different alignment properties to help summarize what we're using where. But just stick with me for now. The align items property aligns grid items inside a grid cell along the column axis. The CSS property looks like this, where at the moment, the value start is being used. Looking at this in diagram form, we have our grid container, our vertical grid lines, our horizontal grid lines, and these define our grid cells. We then have our grid items inside the grid cells, and along the column axis, these grid items are at the start of their grid cell. So let's now take a look at the different align items values. We have align item start, where our grid items appear at the start of the grid cell along the column axis. We have align items end, where our grid items appear at the end of the grid cells along the column axis. We have align item center, where our grid items appear in the center of the grid cell along the column axis. And we have align item stretch, which again is the default value, and where our grid items will stretch the full height of their grid cell along the column axis. So let's go play around with this inside VS Code. Okay, I'm back inside the app.css file. I'm just going to go remove justify item center, so we can focus on the align items property. I'll refresh, and we know by default, our grid items will stretch the full width of the grid cell along the row axis. Now, at the moment, applying align items with a value like start won't do anything. And that's because our grid item currently is the same height as the grid cell. Just checking this out in DevTools. Our grid item is setting the height of the grid cell, so there is no space along the column axis to align the grid item. Now for this to work, I need to go add some height onto our grid container. Let's go add 500 pixels. It's also going to be easier to see the effect of align items if I just comment out the gap. So I'm going to do that and refresh. Let me just comment out align items. And you can see by default, our grid item is now stretching the height of the grid container. If I add align items back in and set its value to stretch, which is the default value, you'll see there's no change. Let's go play around with the different values now. I'm going to change this to start. You'll see that the grid item now appears at the start of each cell along the column axis. Let's change it to end. To better see this, let's open up DevTools. You can see that each grid item is now aligned at the end of each grid cell along the column axis. And the final value is center, where you can see the grid item is centered inside the grid cell along the column axis. And just like Flexbox, you can of course use these properties together. So let's go set justify items to a value like end. I'll refresh, and you can now see our grid item is at the end of the grid cell along the row axis and is in the center of the grid cell along the column axis. So let's now take a look at some grid alignment guidance. It is common to use grid alignment properties when one grid item is larger than another. Looking at this web page here, this content is inside a grid container. We have our two grid items. I'm going to add in the horizontal grid lines and vertical grid lines. And you can see the image sets the height of the container. So align items is used to center this grid item along the column axis. Let's go check out an example of this. So on this page, I'm going to scroll down to this section here where we have a grid layout. I'm going to open up DevTools and I'll select the grid. You can see this image on the left is setting the height of this row. And the group text on the right, which is the other grid item, has a height smaller than the image on the left, which means that there's space for this grid item to move along the column axis. Looking at the CSS properties, you can see a line item center is being used. If I turn this off, you'll see the content moves to the top. Now we know the default value is stretch, so if there was background color on this grid item, you would see that background color be the same height as the image. But this is a great example of where we're using the align items property to center a grid item when the other grid item sets the height. Moving on to the next piece of guidance, it is common to use grid and flexbox in parallel to achieve more precise control of layout. Looking at this page as an example, all of this content would be inside a grid container with our grid items. I'm going to add in our grid lines, and for this layout, grid controls the overall structure. But now instead of using grid alignment properties, we can use flexbox inside the grid items, where flexbox controls the alignment inside the grid item. Our grid item would essentially be turned into a flex container, where we would have these two flex items. And then we can use the flex properties for spacing and alignment, as well as properties like gap. So let's see an example of this in the browser. So on this page, I'm going to scroll to the bottom, and we have this review section over here. I'm just going to zoom out a bit. I'm going to open up DevTools. I'll select this section. You can see it's a grid, which is controlling the overall structure of this section. If I expand this, you'll see each grid item is a flex container, where Flexbox is being used for precise controlling of the flex items. And the same thing for the grid item on the right. This is also a flex container, where once again, Flexbox properties can be used for precise alignment. So let's build the next summary card, grid cell alignment. In this chapter, we looked at the two grid cell alignment properties. The first was justify items, which aligns content inside a grid cell along the row axis. We saw there were four possible values. The first was start, where our grid items are at the start of the grid cell along the row axis. There was end, where our grid items are at the end of our grid cell along the row axis. There was center, where our grid items were centered inside the grid cell along the row axis. And then there was stretch, which was the default value, and our grid items stretched the full width of the grid cell along the row axis. The second value we looked at was align items. This aligns content inside a cell along the column axis. The first value we looked at was start, where our grid items were at the start of each grid cell along the column axis. The next value was end, where our grid items were at the end of each grid cell along the column axis. The next value was center, where our grid items were centered inside the grid cells along the column axis. And the final value was stretch, which is the default value, and is where our grid items stretch the full height of the grid cell along the column axis. So let's go use the grid alignment properties on our Quill homepage. We have our grid container and our grid items. We've already established some vertical gap and some horizontal gap. So to achieve the layout we want here, we need to go position our grid items inside the grid cell. Now, just like the other examples we've seen throughout this chapter, the image is setting the height of each row. This then creates space along the column axis, that is vertically, for our grouped text. So align items is used to center the grouped text inside the grid cell vertically. Now the width of our image is also less than the width of each grid cell. In our project, we're using the fractional unit to define our columns based on the full width of the page. Now for our desired design, we want to center our image horizontally inside each grid cell. And because there's space to move horizontally, that is along the row axis, justify items is used to center the image horizontally. So let's go add this to our project. Alright, so I'm back inside our app.css file for the Quill homepage. We have our grid properties here inside the CSS file, and you can see the grid on the features section over here. I'm going to open up DevTools so we can see what's happening with our grid cells. Now for the height of each row, the image is setting the height, which means that for the group text on the left, there's vertical space for the group text to move vertically along the column axis. Inside the grid cell on the right, because our grid container is expanding the full width of the page, and the columns are using fractional units, means that there's space inside the grid cell horizontally, so our image can move along the row axis. Let's first go center our image horizontally along the row axis using the Justify Items property. I'll grab Justify Items and set its value to center. I'll refresh, and you'll see the image has now centered horizontally inside the grid cell along the row axis. Now, of course, Justify Item Center is being applied to every single grid cell because it's set on the grid container. We just don't see the effect of this on the text because the text is currently expanding the full width of the grid cell, so there is no space for the text to move. Let's now vertically center our text using Align Items. We'll set its value to center, and I'll refresh. And you'll see now our text is nicely vertically centered inside the grid cell. And once again, Align Item Center is also applying onto our image, but because the image is setting the height of the container, there is no additional height for our image to move up and down along the column axis. So Align Item Center has no impact. Alright, let's go check out our page in full screen. So this is starting to look great. Each text is now vertically centered, giving nice visual balance between the image and text, and each image is also centered horizontally inside its grid cell. Let's now continue by learning about how to align the entire grid structure within its container using grid alignment. We'll be discussing the Justify Content property, the Align Content property, and items versus content. So what is grid alignment about? Entire grid tracks can be aligned and distributed when there is extra space in the grid container. Looking at this in diagram form, we have our grid container, our grid items. I'm going to add in our grid lines. We have our grid rows, and we have our grid columns. Now, grid alignment is about how we can move the grid tracks, that is, the rows and columns, when there's extra space inside the grid container. This is different to grid cell alignment we looked at in the previous chapter, which was about aligning grid items inside grid cells. The grid alignment, we're moving the entire grid, that is, the different grid tracks, inside the grid container when the grid container has extra space. Now, as a general rule of thumb, I will say that grid cell alignment, what we looked at in the previous chapter, is a bit more commonly used than grid alignment, as it isn't too often your grid container is larger than your actual grid. But for completeness, we do need to cover this. So let's take a look at the first alignment property, which is Justify Content. And this is the same property as we've seen in Flexbox. It's just now being used in the context of grid. Justify Content in CSS Grid aligns entire grid columns along the row axis. So in CSS, it looks like this. The property Justify Content, which is the same as we've seen in Flexbox with a value like space evenly. Looking at this in diagram form, we have our grid container, our grid items. I'm going to add in the horizontal grid lines, and I'm just going to overlay the grid columns over our grid items. So the Justify Content space evenly property is aligning our grid columns, shown in red, along the row axis. So let's now take a look at all the different Justify Content values. They're actually the exact same as what we've seen earlier in Flexbox. We have Justify Content Start, which is the default value. We have our grid container, and our grid columns would be at the start of the row axis. The next value, Justify Content End, where our grid columns are at the end of the row axis. Justify Content Center, where we have our grid columns centered along the row axis. The next value, Justify Content Space Between, places the far left and far right grid items right up against the edge of the grid container, and any remaining grid items are inserted with equal space between them. For Justify Content Space Around, the grid container is essentially divided into 4 equal horizontal sections, and the grid columns are then inserted inside. So we end up with equal spacing between our grid columns and half the spacing between the far left and far right grid columns and the edge of the grid container. The last value, Justify Content Space Evenly, is when there's just equal spacing between each grid column and the edges of the grid container. So let's go play around with these inside VS Code. Alright, so I'm back inside the app.css file we were playing around with in the previous chapter. The first thing I'm going to do is just go remove the align items and justify items property, which we know has to do with alignment of grid items inside grid cells. So we don't need those properties for this chapter, so I'll remove those and refresh. I'm also just going to clean this up a bit. I want to get rid of these gap properties. Now, in order to demonstrate grid alignment, we need to set up our grid so our grid rows and columns have space to move inside the grid container. So in order to do that, we need to make a few modifications. I'm just going to update this height to 800 pixels, and I'm also just going to uncomment the width and change its value to 800 pixels. So now we're working with a grid container with a width and height of 800 pixels. I'm going to also give the entire grid container a background color of black so we can see it. I'll refresh, and let's talk about what's happened. Because our columns are being defined with fractional units, it just means that the width of each column is going to automatically calculate as 50% the width of the grid container. So each of these grid columns are each 400 pixels wide. Because we're not using grid template rows to explicitly define the number and height of rows, the number of rows is automatically calculated based on the number of grid items, which is 8, and number of columns, which is 2. So the result is 4 rows. Because we're not explicitly defining any height, it appears as if each grid item is the full height of the row. Now we know from the previous chapter what's actually happening is that the align items property has the default value of stretch. So if I refresh, you'll see no change. But if I change this to a value like start, you can see the black grid container appearing in the background, where the grid item is just the height of the content. But you can see the actual grid row is being automatically calculated as the height of 800 pixels divided by the number of rows, which is 4. So the height of each row is 200 pixels. I'm just going to go remove the align item start. And what I now want to do is actually go and explicitly define grid template columns and grid template rows in pixels, so that I can ensure our rows and columns have a width and height smaller than the grid container. So let's go update this to 100 pixels and 100 pixels. And you'll now see our columns are only 200 pixels wide, leaving 600 pixels of space along the row axis. Let's also go define grid template rows. We'll keep it as 4 rows, each with a height of 100 pixels. I'll refresh. So we now end up having our grid rows with a height of 100 pixels, meaning the total height of the grid container is now 400 pixels, which means that there's 400 pixels of space along the column axis. So in summary, I've just gone and defined specific heights and widths of our columns and rows, which is less than the width and height of the entire grid container. And this puts us in a position where we now have space along the column axis and the row axis for our grid columns and rows to move. So let's go play around with the justify content property. We'll set the first value to start, which is just the default value, so there's no change. Our grid columns are at the start of the row axis running from left to right. Let's update this to end, and you'll see our grid columns shift to the right. That is the end of the row axis. The next value is center. I'll refresh, and you can see our grid columns are centered inside the grid container along the row axis. The next value was space between. I'll refresh, and you can see our grid columns move to the far left and far right, and if there was a third column, it would appear in the middle. The next value is space around. Because we have 2 columns, this effectively splits our grid container into 2 down the middle vertically, and then inserts our grid columns in the middle of each column. The final value was space evenly. I'll refresh, and this now creates even space between our grid columns and the edges of the grid container. Let's now take a look at align content. And again, this is the same property used in Flexbox, but now applied in CSS Grid. Align contents aligns entire grid rows along the column axis. In CSS, it looks like this, align-content with a value like center. In diagram form, we have our grid container, we have our grid rows. I'm going to add in the vertical grid lines, and align content distributes our grid rows along the column axis. So let's take a look at the align content values. We have align content start, which is the default. And in diagram form, it looks like this, where our grid rows are positioned at the start of the column axis. We have align content end, where our grid rows are at the end of the column axis. We have align content center, where our grid rows are centered along the column axis. We have align content space between, which pushes our top and bottom grid rows to the top and bottom edge of the grid container, with any additional grid rows spaced evenly between these. We have align content space around. This will divide our grid container into 2 horizontally, and then we'll insert our grid rows in the middle of those two sections. The final value is space evenly, which creates even space between our grid rows and the top and bottom edges of the grid container. So let's go play around with these inside VS Code. Alright, so I'm back in the file we were just working on earlier. I'm going to go just comment out the justify content property and refresh. Let's go grab our line content property, and let's first look at the value start. This is the default value, so we're not going to see any changes. And by default, we know that our rows will appear at the start of the column axis running from top to bottom. Let's change this value to end. I'll refresh, and you can see our rows now move to the end of the column axis, which is at the bottom. The next value is center. I'll refresh. This centers our grid rows along the column axis. The next value is space between. I'll refresh. This pushes our top and bottom rows right to the top and bottom edge of the grid container, and then equally spaces any grid rows between these. The next value was space around. I'll refresh. This essentially divides our grid container into 4 equal rows, and then inserts the grid row inside each of those sections. This means we end up with 2 times the amount of spacing between our different grid rows compared to the edge of the grid row and the edge of the grid container. The last value was space evenly. I'll refresh, and this creates equal space between our grid rows and the edge of the grid container. Now I know throughout this topic, we've seen a lot of alignment properties when it comes to grid. So I do want to quickly summarize the differences of the properties, items, and content. Looking at the items properties first, we have justify items and align items. And these are more commonly used in CSS Grid. These properties align grid items when grid cells have extra space inside of them. Along the row axis, we use justify items, and along the column axis, we use align items. The values that each of these can take include start, end, center, and stretch. In diagram form, it looks like this. We have our grid container, our grid lines, and let's say we apply the properties justify items center and align items end. We end up with our grid items inside our grid cells looking like this, where along the row axis, that is horizontally, justify items is centering our grid items inside the grid cell, and along the column axis, that is vertically, align items end is placing the grid item at the end of the grid cell. So justify items and align items are about aligning grid items inside grid cells when the grid cells have extra space. For the content properties, we have justify content and align content. This aligns grid tracks when the grid itself has extra space. Along the row axis, we have justify content, and along the column axis, we have align content. For the values that justify content and align content can take, include start, end, center, space around, space evenly, and space between. Looking at an example of this, we have our grid container, and let's say we applied justify content center and align content end. This would mean that our columns are centered along the row axis, which is being defined by justify content center, and our rows are at the end of the column axis, being defined by align content end. Now, justify content and align content only work when the grid container itself has space, so that the rows and columns can move around. This is very different to the properties justify items and align items, which is about the movement of grid items inside grid cells. Now, as I'm sure you're aware, we also use some of these properties in Flexbox. So when it comes to Flexbox, align items, justify content, and align content can be used, where justify items is specific to grid. Just as a quick reminder, align items aligns flex items along the cross axis, justify content aligns flex items along the main axis, and align content is only used when our flex items wrap onto separate lines. So let's now wrap up this chapter with a new summary card, grid container alignment. We first looked at the justify content property, which aligns grid columns along the row axis when there is extra space inside the grid container. The different values we looked at include justify content start, which is the default value and looks like this, where our grid columns, shown in red, are at the start of the row axis. The next value was justify content end, where our grid columns are at the end of the row axis. We then had justify content center, where our grid columns are centered along the row axis. The next value was space between, where our far left and far right grid columns are pushed right up against the grid container, and any grid columns between these will have equal spacing. The next value was space around. This essentially divided our grid container into 3 separate columns, and then inserts our grid columns in the center of these. So we end up with double the spacing between our grid columns compared to the grid columns on the far left and far right and edge of the grid container. To space evenly, this simply creates even space between our grid columns and the left and right edge of the grid container along the row axis. The next value we looked at was align content. This aligns grid rows along the column axis when there is extra space inside the grid container. It's the same values as justify content. We have align content start, which is the default value. This positions our grid rows at the start of the column axis. Align content end, which positions our grid rows at the end of the column axis. Align content center, which positions our grid rows in the center of the column axis. Align content space between, which pushes our top and bottom grid rows to the top and bottom of the grid container along the column axis, and any additional rows would have equal space between these. Align content space around divides the grid container into 2 equal rows, and then inserts the grid rows in the middle of these rows. This results in double the space between the grid rows and the top and bottom edge of the grid container and the top and bottom grid row. The final value space evenly creates equal space between the grid rows and the top and bottom edges of the grid container along the column axis. Now in our Quill project, we won't be applying these properties because our grid doesn't have any extra space. And it actually is fairly common in most web design for there not to be additional space to move